Is I'm going to put about 10 pounds of information into a 5-pound bucket. And I'm going to go very quickly because you guys are remarkable at your knowledge base of the fundamentals as well as the more complex issues of building. Bruce did an exceptional job, of course, of putting together the ideas of the levels of concern and complexity that we have in something as what seems as simple as ductwork and distribution. I loved what he said is, what's the tolerance for leaks in plumbing? I thought that was a great thing. That's a nice job, Bruce. And I think if you think about it, what's the tolerance for leaks in plumbing and what's the tolerance for ducts? And we're like, well, it's okay. And it's not okay. And so we're going to talk about some things today, and I'm going to go through this pretty quickly. What I intend to cover, I guess, is a little bit about what we see happening and what's happened, where we've been, where we're going, a little bit about the evolution from failed buildings to doing things properly. And today at the project that we were at, the co-housing project, there was a lot of things. Did everybody got there, didn't they? Most people. Taking a look at some of the things that they really tried to do well, showed and demonstrated that you can do it, they can accomplish it, and they were doing a fairly nice job of pulling that together. So we're going to talk a little bit about what's happening and where we're going. You guys know where we're going in terms of code issues and the vision for the future. A little bit about building science and the fundamentals, some whole house design methods. Methods to build better. I took out the HVAC section because Bruce did such a phenomenal job of talking about that. I'm just going to leave that out of there because you don't need me to talk about that. A little bit about testing and blower doors and verification, and just a little bit about what the marketplace is seeing as far as our new client. And I'm just going to talk about that briefly for a second, though. Do you think today's consumers, the consumers of houses today, because that's in some ways what some of us represent, is the ability for us to carefully represent the consumer and the person who maybe lives in our jurisdiction or somebody that we're helping make sure that their house performs well. Isn't that kind of our responsibility to them? To have the knowledge base, to implement that, and to know where it needs to be, not just where it is. And I think it's important for us to feel comfortable pushing the envelope a little bit. Isn't that okay? Is pushing the envelope a good idea? If you don't, you get to be really comfortable with exactly where you are. And where we are is not where we need to be. There's absolutely a fact in that, right? Buildings are too leaky, ducts are too leaky, energy use is too high. We got to fix that. And we're really comfortable about doing it over the next 20 years, right? When should we be doing it over? The what? The next year, right? Is it possible? Is it possible? Of course it's possible. What's the only obstacle that we have in terms of moving from where we are to where we need to be? What's the only obstacle? I think I mentioned it yesterday. It's NAHB. Forget those guys. Even though he's right. What's the greatest obstacle in us moving to where we need to be? Attitude. It's attitude. It's choice. We have choice. So the choice is that we're going to make buildings better. And that's just the way it's going to be. We're just going to do that. We have a country dependent on oil and energies outside of our country, domestically, financially. Everything that we need to do, from comfort, health, safety, revolves around us building better buildings. So let's go, right? Isn't that the only thing in our way? It's just choice. And we all want to put all these obstacles in the way. Well, there's not enough guys trained, the equipment, it's going to be hard. Is there anything that this country has ever done that when it really mattered, that it wasn't hard? But when you get done with something that's kind of hard, doesn't that feel amazing? They go, no, that wasn't that bad, right? Do you ever make things harder than they really are? We all do that. We're extraordinary at that. Anybody good at procrastinating? I excel at that. I'm one of the best on the planet Earth at procrastinating. But then there's something when you get done, don't you wonder why you procrastinated? When you get done, you go, why did I do that? I should have just got it done. So we're gonna move in that direction. And what's changed, I think, is something that's interesting. If you look back, let's say 30 or 40 years from a materials perspective. Sheathing. OSB has only been around for 25 years, basically. Does anybody remember when it first came out? Yeah, you bought the 7/16, you added water, you get 1.5 inches. Remember that stuff? Yeah. So this was a problem that an industry said, we've got this really cool stuff, just don't let it get wet. Don't ship it to a job site because then it's going to sit outside and that would probably be bad, right? Did a lot of people do it anyway? And who fixed the problem? Was it code that fixed the problem? Lawyers. Industry fixed the problem, right? Industry fixed it. They said people are going to go back to plywood if they have to power plane OSB. Ever tried to power plane swollen OSB? Doesn't work that good. So the idea is to say sheathings and materials have changed. So we looked at product changes. That evolution of materials have changed our building dynamics. Something as simple as plywood being done for racking strength and some other benefits, mostly speed, changed the ability for the building to breathe, right? You know how many times I teach and work with builders? I talk to almost 10,000 builders a year. So many of them still say, you know, we ought to just build them like we used to. I still hear that. Isn't that a good idea? Let's just build them like we used to. I think that'd be awesome. Is that going to work? Doesn't matter anyway. We can't do it, of course, because code's not going to let us, right? So old buildings that were sheathed leaked rapidly, energy flowed through them, air flowed through them, dried quickly. That's the lock. We looked at thermal insulation. We had thermal insulation in the building. Does that change the drying capacity and capability of the building? That's pretty straightforward. So we have to move in that direction. How about cladding changes? Horizontal lap wood siding to cement siding to cultured stone to traditional stucco through synthetic stucco to all the other cladding systems. Does a cladding system affect the durability and the performance of a building? How many buildings are you seeing an architect sends a plan out and there's 3 different types of cladding on the same house? The same building. So if you have 3 different claddings in the same building and we all agree that they perform differently, is there anything different behind the cladding? Does one need a vented rain screen and the other one not? So how do you line those up? How do you make those happen? And the changes in cladding are also important. On the equipment side, we do know that HVAC changed. Now, after this last few days, do you think there's going to be more people adding air conditioning in the Pacific Northwest? They say in the Pacific Northwest, the saturation went from about 25% air conditioning about 15 or 20 years ago to almost 70% now, and as of tomorrow, it'll be 100. You know, there's nobody who's going to do that, put up with this anymore. But it's interesting, that saturation of air conditioning. In doing that, did that change the dynamics of buildings? Once we installed central forced air and moved air all around and stuck air handlers in garages and stuck air handlers in crawl spaces and had the brilliant idea of putting air handlers with the ductwork in the attic. Isn't that a brilliant idea? Let's put the mechanical system for cooling in the hottest place on the planet Earth. Death Valley's cooler, isn't it? On a day like today, if the attic's running 140, what do you think that air conditioner's doing? It's fine. I've got like R6 on the duct. Awesome. I should be fine, right? In the morning when the thing calls for cooling, what's the temperature of the air inside the duct in the attic? It's 110 degrees in the duct and it's below. And so the first thing that happens is before you cool the house, you heat it, which is a brilliant idea, isn't it? So it's just interesting that we've accepted that as an approachable method. Can we put the ducts in the attic? Well, everybody does it. Everywhere I travel, the Pacific Northwest, the Southwest, everybody's putting mechanical systems in attics, and great big ones too. You're in the Southeast, they're still doing it, aren't they? Mechanical systems in the attic is a really bad idea. I'd love to say no more paneling of floor joists and no more mechanical systems in the attic. Who services the mechanical system in the attic? The guy that loses rock, paper, scissors, isn't it? It's a day like today, and the air conditioner's down. Who's going to go up and see how it's doing? They're in the truck. Oh, God. So that guy's going to die that day, right? How many of you would work in a 140-degree space? You're like, oh, I'm in, right? Yeah, Bruce would. Yeah. He needs a little personality improvement, doesn't he? Bruce, he's got, you know, what was funny what he said? He said, when I have my downtime, I start doing research on HVAC. Dude, you totally need a life. They have bikes and things like kayaks and stuff. He's awesome. Exhaust capacity, has that gone up? How many of you guys today noticed in the co-housing building the size of the fan in the kitchen? Was that impressive? It said right on a very fine print, it says, be careful, it will suck small animals into this grill at high speed, right? It's like 3,500 CFM turbo sucker, right? And so right next to it, did you see the makeup air unit? And did you also see that in the common space was the fireplace with folding glass doors with 1/4-inch gaps in the door? I said to the guy, I said, what does that burn? He goes, wood, gas, no problem. I go, huh, that ought to be good. Where's it going to get its combustion air from to make sure that when the fan comes on, all the pressures are fine? He goes, you see that little duct out there, the little 4-inch duct that's been smashed from behind the fireplace and running back and forth? He goes, right there. I go, that ought to be fine. You think? You think that a fully burning fireplace consuming maybe 200 cubic feet per minute for air is going to be fine just through this little 4-inch duct that's been smashed in the wall cavity when the fan's running? What do you think the pressure in that house, that building's going to be? Have residential buildings found commercial cooking equipment in residential buildings? There's a brilliant idea. We require makeup air in commercial buildings, but residentially it's not that big a deal. The air is different. Right? So all the physics, my whole point here is about how the physics always apply the same way. Whether gravity pisses you off or not is completely irrelevant. Right? It's the deal. So then when we argue with it, it seems kind of silly. So be careful of exhaust capacity. Finally, we've seen a really big challenge with our process and systems. This has become one of our greatest nemesis here, is that in the older days, we talk about framing and reducing waste on the job sites. Talk to the old guys that were way, way back. They'd finish a job site with a couple of 5-gallon pails of waste. They weren't trying to get green points. It just made good business sense not to waste. Now the pile's gotten bigger in the places, and now we're all concerned about material use, which we should be. So how do we get back that process of, I asked builders, I go, what do you think that big pile of garbage and wood and byproducts are in the front of the yard? And they go, garbage? And I go, no, actually it's what? Money. It's money, of course. It's a great big pile of money. So it's a big pile of money out front. They go, well, it doesn't really matter to me because the trade contractor that's doing the framing bids the job, so it really doesn't affect me. It's in his bid. Somebody pays for that. Right? It's not just there's this magic fund that pays for waste and excess, is there? Who paid for that? The owner, but in reality, it came out of the pocket of the builder who had the potential profit margin to include that. So it is a process problem, is how do we make sure that everybody's on the same page? And that's one of the greatest challenges the code creates, right? Is that as we improve the expectations of what we want a building to act like, we have this more and more fragmented trade contractor base. Oregon just passed a requirement a little while ago about requiring all trade contractors in the state of Oregon to be trained. All trade contractors, plumbers, electricians, installation contractors, framing contractors, they all have to be trained on the fundamentals of energy efficiency and durability in building science. 40,000 contractors in the state of Oregon. Isn't that amazing? Now, how are they going to pay for that? It's irrelevant, isn't it? No, it's very relevant. It really has to be something that we fund, both online training, classroom training, however it gets done, but those trade contractors need training. And if we have a process problem, as we improve codes, we have to also improve the process. Bruce talked about something and he just said, training. Once you get somebody the knowledge to understand the fundamentals of the box he had up here, did it make sense? How can you argue with that? And you're like, well, what happens when the gauge says this? And you're, that's probably not that good. And you're like, no, it's not that good. So is 12% acceptable? Absolutely not. Absolutely not. 6. 6 is where we start for his duct leakage. So Bruce is trying to be really gentle. And I said, I gave him a bad time. I said it's 6%. We have, as I said, a complicated business. So there's an extensive collection of materials, challenges in building, changes in code, communication obstacles. Here in Oregon, there's a large concentration of Russian immigrants that are here, and a lot of them in the siding industry. And I was on a job site, and I was talking to the guy about putting on the rain screen stuff. And I said, do you know how to do it this way and this way? Yes. And I said, have you ever put it in this way so that it connects to that piece? Yes. How did you get to work today? Yes. Right? So it was okay because he was a phenomenal worker, did a great job, but how am I going to communicate to him what needs to be done when the fundamentals of language are the barrier? So how are we going to get that to change? And what are we going to do about that? Pictorially, I'll show you an example of some opportunities of doing that. We've got market expectations and client expectations. So when someone spends a few $100,000, a third of $1,000,000. Those co-houses today, $345,000 to $420,000, $430,000 I think was the price I saw in the 3-bedroom. Are there people that have expectations for that building? What are they going to expect it to be?
Air conditioning.
Yeah, I think so, but it's just a challenge. Now that they have hydronic in floor and no provisions for air conditioning, are they going to be have some challenges there? I think so. Yeah, I think this week could be bad for sales. Personally, that's just personal opinion. But what are some of those expectations in terms of anybody spending any money for a house today?
Quality.
They want to be
Quality.
Comfortable. Do they expect water intrusion and leaks? And when they do, are they pretty frustrated about that? So their expectations have changed by a couple of reasons. Price drives expectations, but so does knowledge drive expectations. They say people are spending between 5 and 6 months online before they buy a house or a building to make sure that they understand what it is they're buying. So what is the odds the trade base and the builders are keeping up with the pace of the client who's looking to buy a house? What are the odds of a client coming in to buy a house knowing more than the trade contractors or the builders? Is it possible? It's probably good. It's actually happening as we speak. So the complexity is really, if we look at green buildings, they try to encompass all these pieces. And we're looking for kind of an optimum vision on sustainability. So energy efficiency is important. We know that healthy indoor living is important. The human body respirates about 9,000 liters of air a day. In my respiration cycle, should every house built today have a continuous supply of ventilation for human occupancy? And should it be delivered to all habitable rooms? Because if you dump fresh air in one location, how does it get to the children's bedroom with the door closed at night? Have you ever been in a teenager's bedroom with the door closed after 9 hours of sleep? Boy, that room needs some fresh air. Yeah. Yeah, I had 2 boys. You go in those rooms and you're like, wow, it's just human respiration and all the other stuff going on, right? So do we want to supply a fresh air supply to living space where people sleep and live? Should we wait for that, or do we need to do that today? Because do human beings need a continuous supply of fresh air that somewhat matches my respiration cycle? Now, does it have to be very much? Very small amount of fresh air supplied. Can we get that through leakage? Or could a bedroom be only exfiltration, not infiltration? So understanding building complexity is that we tighten the enclosure. I believe we need fresh filtered air supplied to people's living conditions and living space. I don't think today's house, with maybe 2 windows, has adequate levels of ventilation and fresh air as the enclosure gets tighter. Did any of those spaces smell a little chemically to you? That's a technical term, chemically. Did some of them smell a little bit? Wow, some of them were so powerful, it was really amazing. And I asked the guy, well, is that a low VOC painter? He goes, well, that's the finish that we put on the floor. It's nasty stuff. That's what we want, more nasty stuff with operable windows. I think it's a phenomenal concept. So materials that are beneficial to the environment, that's that green point chasing thing. You heard me talk about that the other day. Boy, I tell you, when bamboo starts taking a precedence over insulation, I have issues. Okay? Bamboo floors actually don't perform that well. Now, did you look out the window of that one unit? They had planted bamboo. That's awesome. That's where it belongs. Just plant it, you know? It's cool. Just don't, it's the silliest thing sometimes. Durable design. I mentioned this yesterday just a little bit, but in terms of longevity, we all agreed, I think, I'm going to make this assumption, that houses should last at least 100 years. I think that's a fair assumption. Can they do that? Can buildings last 50 and 60 years? Because no place else in the world has been able to accomplish that, right? We're going to push the envelope. We're shooting for 100, right? When I asked that question for over 20 years, I've asked it for every group I've spoken to. On the East Coast, they give me longer time frames than on the West Coast. Why is that? Are there any houses? Yeah, are there any houses on the East Coast that are older? Yeah, I live in one that's like 250. You're like, okay, but we can't do that again. That's hard. That's going to be hard. And people go, well, that's because you're insulating them up and you're making them too tight. I'm like, wait a minute. Do you think in the year 2009 and beyond we can figure out how to build houses that last for 300 years? And what's the only cause of a failure in a building? What's the primary cause of building failures? 90% of the time we know what causes buildings to fail, which is what? Mismanagement of moisture. In the vapor state, the liquid state, we know that they're attached to soils. We build basements, crawl spaces that are actually excavated pools in heavy wet soils and go, it's fine, right? So kind of looking at our structures, if you build wood frame buildings that are thermally insulated, is that different than a masonry built building that has a different performance expectation? Does a CMU building perform differently than a wood frame in terms of durability? In other words, does masonry have the ability to store a little bit of water and then maybe give some of it up after a while? Does a wood frame building have less tolerance? Does a steel frame building have even less tolerance? So looking at the way we design a building has to have a direct correlation to our expectations. Would you build a really, really solid, incredibly well-built doghouse for a dog that's just on his last leg? If you get the puppy, you go, I'm going to insulate this sucker good, right? It's just an interesting variable. Now, in sustainable sites, is it possible that we can design communities with an orientation towards understanding that in the future we might actually utilize the sun as an energy source? I mean, this is a stretch, I understand. But if we did that, would that be possible? And are we seeing more people consider that? Do you think, honestly, 20 years from now, we'll see a larger concentration of photovoltaics on the fly into Portland that'll actually be on roofs? Do you think that we'll see more of that? I think so. I think when you look at the simplicity of design and everything, everybody's waiting for us to come up with a new fuel option that we don't have to deal with that. We can just suck hydrogen out of the ocean. We're going to be fine. We're all waiting for physics to kind of keep up with us and just go, we're almost there. Just like do a few more nukes and we're almost there. So I think really amazingly insulated, well-built buildings is the future, isn't it? Because are we going to see a substantial increase in our use of electricity? Just as a lifestyle? Yeah. You say our electric consumption. Well, cars maybe in the future, not that far away, be running on electricity as well. Talking about grid storage of power and everything else. So if we look at buildings, they really need to be improved. Finally, the water efficiency thing. You know, they say and I should ask my brilliant new friend over here. They say that about 1/2 of 1% of the water on the planet is safe to drink. 1/2 of 1%. Isn't that something? So do you think we should probably be better stewards of the use of water? And then even in a place like here, should we be doing a better job of that? Everybody thinks because it rains a lot, you don't have to worry about it. And it matters everywhere. So water efficiency is important. So in terms of defining our path and where we're going to go, do you think that it's important that sustainable projects really are trying to address all of those pieces in kind of a little more harmonious cycle? And when is it going to take us? And what is it going to drive us? What's going to drive us to do that? And I'm afraid that we keep giving ourselves too much time. We keep waiting for something. And all that is we keep waiting for something to get easier when to do this is a little harder than what it's been. And that's okay. It's okay to make things a little more difficult. When you push, people push back, and then you usually find a spot in the middle. Is that true? But if you don't push at all, we give people too much room and say, see, I knew it wasn't that important. Only when we push do we get the ideas pop up. Now I'm going to go through these really quick because you all know what they are, but tight construction is sealing buildings up, sealing up bypasses, and testing them. That's essential. Improved thermal insulation systems. I'm going to make this statement because I absolutely believe it 100%. Fiberglass bats, sorry for the CertainTeed folks because I love you guys. Fiberglass bats should no longer be allowed in buildings. Okay? Why do you think that's okay? Are fiberglass bats well installed?
They can be.
Have you ever seen them?
Yes.
How often? Not often enough. Come on, I am probably in as many buildings as anybody in this room, and I would say that I see fiberglass bats smashed, compressed, and jammed in. Let's be honest. Can you take a bat 14.5 inches wide and customize it for the cavity that happens to be custom throughout the building and do it well? The guy said today one of the most difficult things we have is trying to get the guys not to smash and compress the bats. As blown-in insulation, which has been around, I put blown-in insulation, blown-in fiberglass in my first house in 1986. CertainTeed's got a phenomenal record at blowing in beautifully installed, well-installed fiberglass blown-in insulation. Just as because remember I had the microphone, I get to say stuff? I don't know if you guys got that the first time. It's like that Adam Sandler movie, I get the microphone, you don't. But here's what I'm trying to say about this. Let's be honest about this. The Oak Ridge National Lab said that about 4% compression in fiberglass insulation can result in up to a 40% reduction in insulating value. That just was with Oak Ridge. But if you look at the idea of putting in the insulation, could we look at the fact that blowing in the insulation in the wall cavities, cellulose, fiberglass materials, make a substantial improvement at a modest cost? Sprayed insulation. Should it be done? Should it be done? Of course it should. It should be done. And why are we all afraid to do that? Because everybody thinks it's about cost. Is it really that much? It's not that much, you guys. Blowing in the insulation in the wall cavities assures the insulating value. If you're a heating contractor, how well would you like to know the insulation was well installed? Because if you're a heating guy and you're doing the load calculations and you looked at the insulation poorly installed, what would you do? That's right, I'd oversize. I would. I'm going to go, you know what, the last thing I want is a call from the guy saying, hey, buddy, you blew it. You undersized it. So you're like, okay, when in doubt, add a ton is a pretty good motto, right? And if there's any doubt, I would add a ton. But if the building was remarkably tight, well insulated, could we ask that the HVAC systems are remarkably well installed? Would that lower their installed cost and help us with this issue that we're having now about combustion safety? Atmospherically vented appliances should no longer be allowed in residential buildings, neither should orphaned water heaters. Because a water heater that naturally aspirates to the outside in a tighter enclosure is now being affected by things like clothes dryers, central vacuums, and a simple range hood in the kitchen. Is that true? Is it true? Yes, it's true. As you improve the tightness of the enclosure and you increase the possibility of depressurization of the space, what's the natural draft pressure of a water heater running by itself? Bruce, how many pascals?
3 pascals.
About 3 pascals of stack pressure. So if I have a water heater fired and the stack pressure is about 3 pascals, what's the possibility of me having a central vac and a clothes dryer running and depressurizing the house to 7 pascals negative? What's the odds of that water heater drafting? So the answer is put a really big hole in the rim joist, right? Because here's the challenge. We all assume that the combustion airline understands how much air it's supposed to bring in, doesn't it? But when we depressurize the building, doesn't it uniformly depressurize the house on all surfaces? So does it know where it's supposed to come from? So will a 6-inch duct to the outside provide enough combustion air for that device, or could it still backdraft as it's drawing from all the other sources, like the garage and the attic? So understanding those fundamentals is for us to stop and say, this isn't an opinion, it's not about saving energy, it's also about safety too. In 1994, when Bruce put in Minnesota, he said, we can't outlaw atmospherically vented appliances. Let's just make it tough to do. So he said to the builder, so if you have a naturally aspirated appliance and the CFM capacity is over 150 CFM, what should you install? Make a pair, right? You supply make a pair. And the builder says, well, that's going to be more expensive. Yeah, you know, you could go with this new device called a power vented water heater that's been in the market for over 20 years. It's $138 at Home Depot to go from a conventionally naturally aspirated water heater to a power vented water heater. $138. Is there any savings in the vertical Class B flue going through the roof? And taking it out? Absolutely. Does it reduce the penetration in the roof? And most of the big people that really sit down and do a cost comparison, a power vented water heater and a naturally aspirated water heater are installed at the same price. So if they're the same price, what should we be installing? And encouraging. Doesn't have to be code. Should we be strongly encouraging that approach? Have you ever seen somebody try to put a flue through a house, a 2-story house? I see them in the garage go, especially here, out the garage, up the wall, up through a little closet space, and then I see a return duct next to the cavity, and I go, okay, bad idea, right, Bruce? So enhanced durability, we talked about that, how you wrap buildings. Oregon now is looking at the provision of saying that there must be a minimum of an 1/8-inch drainage space behind all cladding systems, and rain climates above 40 inches should be a vented rain screen. Do you think that's going to happen in wetter climates? Will there be an evolution of people wanting rain screens behind the cladding systems like you saw today at the co-housing project? Well, you see that that's where things need to go. So I'm just going to say this is something that you'll start seeing. Why today did that housing project have a vented cladding? They had cement cladding with a house wrap and a venting space behind that cladding. Why would they do that? Are they required to do that by code? Is it a really good idea for the building owner to do that? Because it rains here enough to provide that. Was he made to do it, or is it a business-driven decision? High-performance windows, solar heat gain coefficients, U values, visible light transmittance, all stuff that we've got in place thanks to the kind of industry looking at NFRC as an idea to normalize performance, at least so that we could look at the sticker and have an idea what it meant. And it actually means something, and now we're including that into our software, including our calculations, and it makes a lot of sense. So I think that those are great steps. Efficient heating and cooling systems. Like I said earlier, don't think that there should be anything but a sealed combustion, 90% efficient furnace installed in every building built, and that's the way it goes. Would that have an impact on our consumption of energy in this country? So let's do that. Let's do that. Now the differential, everybody thinks, I heard somebody today tell me it's $1,000. I think when it started happening in Minnesota, going to the sealed combustion furnace, they started having 90% efficient furnaces that were about $200 to $300 more per furnace. That was in 94, 95. Yeah, and so the gas utility provided a small rebate, and so the overall differential in cost of not running the flue through the building ended up being a near wash to get high efficiency. So everybody goes, oh, that's like $3,000. No, it's not. Do the math. When we started and that first code came out, the Builders Association came up with a little thing in the newspaper. It said $10,000 to meet the new energy code. All these people are going to be out of housing. What a disastrous idea. So everybody's like, oh, okay, maybe we shouldn't. So we actually had a builder say, why don't you go price this for us and come back? The guy was like, well, it's like 3,000. So that's better than 10. So can you sell 3,000? Probably. Okay, so let's give it a shot, because in the market economy, we can have those expectations. So we should be doing that. Bruce talked about ducts and mastics and sealing them. I love the idea of putting it down on nickel thick and putting it on the ducts, and I think that's really important. Is it a difficult task? It's more complicated than not doing it. It's a messy task. Is it something that should ever not be done? That's what's interesting. You know what our benchmark is? Not doing it. Well, that's a good reference point. Yeah. I either don't do it or I do it. Doing it's hard, so no. Right? Should not sealing the ducts even be an option? Of course not. What we should do is say, well, of course you have to seal the ducts, and you shouldn't be putting them in wall cavities. There shouldn't be a wall cavity returns. That shouldn't even be available. I was in Utah and I see floor cavities panned off with wire holes running through them, right? That's a good idea. We're just going to suck the air out from anywhere it wants to, right? It's like having a bucket with holes in it, trying to keep it full of water. It's silly. On the ventilation side, we already talked about that. Energy recovery ventilation has been around since 1980, at least in terms of general market acceptance. In Minnesota, the saturation for energy recovery ventilation is about 70% of the homes get energy recovery ventilation, have for the last 10 years. It's a doable thing, but you don't have to go quite that far. We could say, let's just provide a good supply of ventilation, a good supply of fresh air that allows a modulating damper on the return to bring in 5 or 10 minutes of fresh air from the outside, filter it, and distribute it to all living spaces when people are occupying the space. Done, right? Shouldn't be hard, and it isn't hard. It's easy to do. Is there a Honeywell person in here? There was a Honeywell person. Yeah. Did you guys have like that damper assembly? You've got the control. It's called the XY85-47. You guys got to get new words for this stuff. But yeah, they come out with a super number that nobody can remember because I'm always trying to remember it. But there's a really cool controller that they have with a motorized damper in the return, and it operates with the air handler, and it opens the damper to the outside, turns the furnace fan on for 10 or 15, 20 minutes, shuts the damper, closes off the blower assembly. If air conditioning on a day like today is running for 4 straight hours, it only opens the damper just long enough to provide fresh air and closes the damper back up while it's still in the air conditioning mode. That's pretty inexpensive, isn't it? And we have to control, I think, that fresh air intake on the return side. Efficient heating of water. We know that this is starting to add to our overall load. We're seeing the percentage of water heating actually increase substantially in terms of the overall energy load because people are having a lot of demand for hot water. So tankless, high efficiency electric or power vented gas is a piece of cake. The tankless water heater has been around for 20 years. We're just starting to see more of them. Appliances, Whirlpool appliances, the horizontal access machines. Imagine something using 60% less energy and 60% less water. Whirlpool is about ready to announce that most of their appliances they're going to sell worldwide as the largest manufacturer in the world of appliances, that they're all rated Energy Star. Should any person that installs an appliance that's going to last for 15 to 20 years be a high efficiency appliance product? Imagine what it's going to be like 5 years from now or 10 years from now in terms of the life of that product. We should install the lowest efficiency we can for cost today so that when the price goes up in a few years, we're going to go, now we're upgrading. Right? So in the world of new construction, new buildings should be remarkably efficient. Is there a return on investment when there's a 60% reduction in energy to washing clothes? Less soap, less water, more efficient operation of the appliance. Lighting, we've got complex fluorescents, LEDs. We have all discussed the daylighting. I know that a complete glass building that can achieve platinum is remarkable because we have daylighting. So personally, I think that we should really look at improving, and the idea that complex fluorescents and improved lighting systems that are long-lived, just a fraction of the energy use should be something we do. We talked about water efficiency. How many of you still see sprinklers running while it's raining? People sprinkling the yard while it's raining. Anybody see that? Do we have the technology to shut the sprinklers off when it's raining? It's amazing. Little teeny sensor for $50 that mounts on the gutter. When it rains, it shuts off the sprinkler. Should we do that? No. No, we should run it through the city municipal water system and then run it on the lawn while it's raining. It sounds brilliant. Why would we not spend $50 to make sure we're controlling that? Is that an easy thing to do? Why do we not do that? Do we need a law to do that all the time? We're always looking for a law. We need like a law to make us save water. And it seems like an interesting thing. It should just be, in some communities now around the U.S., we're seeing that there are minimum requirements. You're not allowed to install any sprinkler system that doesn't have a sensor control on it. That's happening in many municipalities. Site planning and layout, we talked about orientation, making sure that we try to get the idea about breezes and airflow and sun. About renewable energy, about the opportunities of looking at wind generation and photovoltaics. That happens to be a project on the right in Sacramento, done by D.R. Horton. This is a project using tiles that are completely integrated with the roof assembly, and this happens to be groupie homes in Rockland, California. Those 2.4 kW systems on every single house they build. Lennar is now building full communities in Central and Southern California where every single house has photovoltaics. They are now requiring under Title 24 to have remarkably efficient thermal shells, efficiency of appliances at the same time having some photovoltaics. Now we'll see the challenge with photovoltaics in the future being that on really sunny days it's adding to the peak and we're having challenges with them making too much. That'd be cool. The materials and what we have for materials. You see that one in the picture in the upper left? That's the new Georgia-Pacific product called the XJ85. It's an I-joist that allows the space between there to be pre-cut for ducts to be installed in conditioned space. So now when the guy goes, well, I use I-joists, I can't put the ducts in conditioned space, like, I'll be right back, right? So engineering and marketing and manufacturing can solve that problem. Boise has 240 places around the United States that'll take an I-joist and lay out the distribution system. And they use a water laser to cut the spaces between the I-joists so you can get the ducts in the conditioned space. Now there is no excuse for putting ductwork in the attic. There's nothing. You have open web trusses, you have the XJ85, and the open cuts on the Boise Cascade I-joists. So now we have a location to run the ducts. Can we supply the ducts between the floors in a two-story house that the second floor is heated from the floor and the first floor is heated and cooled from the ceiling? Is that possible? Everybody thinks you got to put the cool air up on the ceiling, and that's only when the ceiling is running about as hot as our hotel was. Where's Diane? Yeah, like I said, we were on the 16th floor in my room last night. It was 85. And I talked to the guy at the front desk, and it's 85, and he goes, well, there's no insulation in the roof. It's just going to be hot. What? There's 3 PTAC units in the room that can't keep up with the roof being about 160. It's like it's unusual. To what? Not insulate? I mean, what is that? It's a bizarre concept that we just accept as an approach that shouldn't be happening. So if we look at buildings as complex systems that are interactive and changing, as the mechanical system fires up, it affects the indoor environment, the occupants, and the enclosure itself. Pressurizing spaces. When Bruce talked about HVAC, is it possible to shut the bedroom door and have a pressure imbalance someplace else? What do you think? Of course it is. So should we check stuff like that? Because how big can the pressure differentials be? I see master bedrooms with 2 supply registers in the master bedroom, which has a master bathroom attached to it, which has 1 supply register, which also has a master closet, which has another supply register in it. 4 supplies and how many returns? 1 in the central hall. You shut the master bedroom door, what are the odds of that space being under a positive pressure? The master bedroom's under pressure all the time. You might as well just add some more pressure with the air handler, right? Some of you guys get that? Is that? You're supposed to go, yeah, no kidding, that's totally true. You know, that's awesome. See, I'm just throwing out the truth. But if you think about that, if that room is under a positive pressure during air handler operation, somebody just got it, I think they go, oh, I got it. Just kidding. That's okay. No, I'm just kidding. So if the master bedroom's under positive pressure, what does the rest of the house have to be under? Negative. How much? So if the master bedroom's under a 5, 7, 8 Pascal positive pressure, does that mean somewhere else in the building we have a negative when we didn't intend to it? And how's the air finding that path? Should there be jumper ducts and returns and things that we really design mechanical systems? Well, imagine if we make the space more energy efficient, does that reduce the number of supplies we need in the bedroom? Which reduces the size of the relief pressure from the transfer grills. So see how those all work together? Smaller, more simple systems for very efficient buildings that have less overall system pressure. That's a good strategy. So we're trying to find solutions to the entire thing as in a systematic way, looking at the buildings in complexity. All walls that we build need to handle all of these characteristics in every wall system, regardless of how it's constructed. Commercial, residential, everything. Every wall system needs to control the flow of air, heat, water, and vapor, rain penetration, light and solar gain, noise, durability, and provide strength, rigidity. Are those fair expectations? The list was published in 1954 in the Canadian Building Digest, in CBDs. So that list there means that every time we build a wall assembly, we should check off those pieces. Yeah, how are you going to control airflow? Don't know. How about heat flow? I'm insulating. Good job. How about water and vapor flow? Is that directly correlating sometimes in terms of the amount of moisture in the space as well as the airflow in that space? Does it go through the wall? Does a pressurized bedroom push warm, moist air to the exterior of the building? Rain penetration. Has that been an issue in the past and continue to be a problem? I'm amazed sometimes where I go out and I see buildings that are still reverse flashed. Denver, Colorado, I was there last Friday on a building site where there is a 3-year-old building, $650,000 in the Stapleton Development Project, the largest redevelopment project currently in the country, with small mushrooms growing on the inside of the wood casing on the wall. I have photos, if you don't believe me. And I thought it was quite interesting. The builder says, well, we did a pressure test and the windows leak. Really? Windows leak? When did that start? Do windows leak? Yes. Which ones? Every single window leaks. So I says, well, how do you install your windows? According to the AMA method, we caulk all 4 sides and then stick it in the window. Beautiful. So when it leaks, it can only leak where? Inside. You go, so I do that math with them. I call that guided discovery. So when the window leaks and it can't get out the bottom fin, where does it go? In. That's probably not good. No, I don't think that's good. Should windows be pan flashed if they leak? Well, of course. How long has pan flashing concepts been around? Pretty long time. I was going to show you some pictures of I was on the roof of St. Peter's Cathedral in Rome, and the windows on the cathedral and the roof were all pan flashed to the outside. They kind of wanted that building to stick around for a while, didn't they? So every window leaks. If it doesn't leak in year 2, it'll leak in year 5 or year 10 or year 15, but the windows will leak. They should leak onto a sloped pan drained to the outside. Period. Are we increasing the amount of windows we're putting in buildings that are wood framed with wood sheathings that are thermally insulated? Do you see a challenge there? So will we continue to see water and moisture problems and mold in buildings as long as we keep doing that? We keep thinking, you know, what's that? The idea of definition of insanity, right, is doing the same thing over and over and expecting different results. But this year, it's not going to like rain as much. Yeah, the builder said to the homeowner in that house, the reason why you have this problem is it's one of the wettest one of the wettest seasons on record. Wow. So there's been a wetter one? Well, yeah, but this is like really wet. A compelling argument, I think, to a homeowner that's got mushrooms harvesting on the inside. Now, this happens to be in Portland. Does this look like a design flaw to you? Okay, so I asked the builder, I said, you know, I kind of think the window's a little too close to the roof. And he's a great guy. He goes, yeah, it should be fine. Now, if you look at this picture in concept, when should it have, of course, been caught? At design, of course. Then when's the next time it should have been caught? At framing. But the framing contractor probably did say something. He goes, hey, the window's framing up pretty close to the roof. You knucklehead. It would have been caught in design if that's the case. Right? Do you think anybody has ordered that window yet? I kind of think so. It's probably sitting in the garage as we speak. What are the odds that somebody, look at the roofer did, can you see? Put the roofing on, put the step flashing against the wall. When he got to the window, was generous enough to cut it at the window opening and fold it in so that it could work, right? What are the chances, do you think, that someone's going to try to install a window in that opening? Do you think they'll be successful? You guys, one of my favorite terms is you can't make this up, okay? Is that happening? I asked the guy, have you done this before? He goes, well, all of those, right? So the problem isn't that he's being negligent. Nobody woke up in the morning and go, today I'm going to do a bad job. What they're going to do is to say, today I'm going to do what I did yesterday. So we seem to continually reinforce poor behavior because people are afraid to call it out. This is bad.
But this is a reverse floor plan and the rain comes from the other direction.
That's exactly what he said. Yes, he said if you saw that we were on the windward side, we're going to be fine. And I'm watching him go through. So I go, you got a little book with those? He goes, I got a bunch of them, you know. So, well, I thought that was pretty good. Thank you for that tip, though. I forgot about that direction of wind. When we look at structure, do you ever think that we add enough framing and Simpson strong ties and turbo shields and super shear? Do you think we've done a pretty good job considering that we could be in a seismic zone? Do you think we've done a pretty good job? Do you think in some cases we probably put just a little more than we need to? Just as a thought. I talked to some of the Simpson guys and they go, you go to a building that's sheared, all the shear walls are in, plus you got the turbo fasteners with 6 bolts going 9 inches with a torque wrench, right? And then in the 3-story buildings, they've got the piece with a little cap on the top where you screw it down with a certain number of clicks so the building in an earthquake can go snap right back, right? So we seem to invest a lot of money. Do you think there's enough footings? That happens to be in Vancouver, Washington, just across the bridge. We toured there today, Vancouver. Anybody on the Vancouver bus? I was on the Vancouver bus. Anybody going to Vancouver? Yeah. Sorry about that. Do you also see the square washers? Because I thought that was a brilliant idea. Because remember how many houses we saw that were being torn off their foundation because of the round washers? That became minimum. So just thinking of the things that we can accomplish. Under-investing in water management. The picture on the right is a project in Minnesota that ends up being 7 years old. I took that picture. The picture on the left is what I would consider to be a reverse flashing concept. Do you think? So if you look at somebody installing that flashing for that band joist, that belly band, against that building, should somebody have stuck that back leg of the flashing behind the drainage plane? So what they're going to do is they're going to put the siding down on top of that flashing, which now, because they're going to put the siding on it, will do what to the flashing? Negatively slope the flashing. And then what are they going to do in the gap between the flashing and the siding? Caulk it. So when you look at that overall idea is to drain the wall behind the siding and store it in the flashing. Am I making this up? No. So if you think about it, what could they do but have flashing? I told the guy, I said, what you need to do, I don't know if there's a pen up here, but I'll just see if I can do this. I showed the guy, so what you need to do is you need to get flashing. Now the options are is that the back leg goes like this. As I said, it slopes up, the belly band sits like this. They put the siding in and caulk it like that, right? All it would take is to go like this, about a 6-degree slope on there like that, have the belly band sit like this, the trim board, the deck ledgers, have the house wrap go like this, the siding sits like that, and you don't do what? Don't caulk. So I said, so do you think you can do this? He goes, I can't get that piece. They don't have that around here. So being a smart ass that I am, I said, do you have the other one, the 90? He goes, yeah. And I put it on the ground. I go, there you go. Right? So this isn't ingenuity, really. This is the guy goes, well, I could have done that. And I go, I think so. Right? So the answer for him was, you can't do it. Can't be done. Nobody's got that kind of flashing. I'll get it for you. Just a minute. I should have gone and done it in the back and then come back and go, I just happen to have some in the truck. It's about $5 more a foot, but I should have charged him for it. Anything. This is in Portland. Guys, I'm not kidding. This is a multifamily project. These are 6-plexes. And the sprinkler guy, I love this. Isn't that just precious? I just love that. Because I didn't know if you knew this, but crawl spaces should be continually sprinkled so we can keep them damp, right? So crawl spaces are a brilliant idea anyway, aren't they? Putting wood-framed houses on damp crawl spaces is a brilliant concept anyway. So I think that that's something we should see if we can get more of. And if it's not wet enough, sprinkle it. I think it's incredible. So these are the picture on the left, 3 years old, 3 years old, and 7 years old in terms of order and time. It's pretty interesting to see how significant the failures are, the mismanagement of water. I'll show you a little detail later on about some stuff. So in the fundamentals, we all know the details pretty clearly. So if we look at conduction losses, we see that the framing, which is significant in number, as we add thermal insulation and pull out the wood, we have a smaller amount of thermal insulation in those buildings. So the overall net R value of the wall systems are, of course, reduced. I'm looking at things like 20% or 25% of the wall area being framed is really a quarter of the building being just solid wood. The opportunity of putting thermal insulation on the outside, you can see a drainage plane there is a rain screen drainage product by DuPont Tyvek called Drain Wrap. It's a vertically grooved house wrap, and they put the foam over the top. Here's a house that's being done in the drainage plane. The windows are pan flashed, and the rigid foam is going over the top of that. We're seeing a lot more of this in improving thermal shell. SIPS panels have been around for, they say, somewhere between 40 and 45 years. SIPS, how many of you guys are seeing SIPS? Of course, is it a brilliantly interesting idea? 60 to 70% less wood, remarkable thermal shell, incredibly strong, incredibly resistant, very nicely built buildings, and we're seeing more of that. I built my house that way in 2001. Convection, as far as the flow of energy, this happens to be a project I was at in Alaska. You can't put more holes in the ceiling and keep the sheetrock up, I don't think, right? This looks like somebody took an Uzi to the ceiling and patched the holes with recessed lights, doesn't it? So that can cause us a little bit of challenge with things like convection and airflow out of the building. And we know the convective looping and thermal insulation, when we stick it in the wall and compress it behind bats, increases the ability for energy to flow through that bat. Even though it says 19 or 21 on the bat, if it's compressed and smashed, it reduces its performance. Solar radiation through windows into the attic spaces. When our attics are so directly connected, we know the solar heat gain coefficient, all this information is now being well communicated, I hope, to a building industry, and we're starting to see that the solar heat gain coefficient is pretty steady in the 0.36 range as a piece of cake. Tale of two houses just shows one house. These two are built exactly the same, of course, in design and thermal shell, and all they did is change the solar heat gain coefficient and reduce the overall load by a ton. Airflow in buildings, as we're all pretty well aware, we have wind effect, stack effect, and combustion in mechanical systems, each one of them competing on a windy day and then looking at stack effect. In a climate like cold climate regions, we know the stack effect alone, air leaving out through the lid of the building has to be replaced through someplace else, whether it's through the foundation and through some base, and somehow that air has to re-entrain itself back to the building. You guys are all aware of this. Air leakage into the wall cavities in a pressurized master bedroom, or a pressurized bedroom or pressurized room at all, carrying with it moisture provides the opportunity for uncontrolled airflow to condense on exterior sheathings. So does that mean that we need to insulate the exterior of the sheathings? Do we need to reduce the pressures in the wall assemblies? Thereby reducing the pressures basically in the room that it's in. Do we need to seal or air seal the penetrations? Which one of those do we need to do? Or is there a combination of all of them help lead you to this? But the idea is that there isn't one we can go, well, they're kind of hard to air seal. You got to go, I know, but the impending damage of uncontrolled airflow is pretty significant, isn't it? Warm vapor in terms of buildings, in terms of lifestyle, provide this kind of failure. The one on the left is 3 years old, the one on the right is 7 again. Can you see this as being a water intrusion problem, or could this be a pressure problem? Do you see any windows in this assembly? It's not a window leak, is it? What are the possibilities that there's a duct running on the outside wall along that band joist that has the ceiling finished to that floor, and all of a sudden the entire cavity became pressurized with a humidifier in the furnace? What's the chance of something that significant? They found a duct going into that cantilevered space. And that's interesting. Pressurized cavity in the rim, pushing air out through all the wire holes and penetrations cause that kind of damage. So looking at pressures and looking at airflow and looking at air leakage, we should be doing this and learning from that experience. Sam Levinson has a great quote. He says, we must learn from the mistakes of others because we can't possibly live long enough to make them all ourselves. Right? I know, I'm telling you. Have you ever tried to tell your kids that? Try to tell them, don't do this. They're like, right, you're just old. Right? My son said, you had 8-track tapes. I'm like, I did, actually. It's terrible. So on the airflow side, controlling airflow, taking the layout of a building and taking an idea, and you can see where I've got those arrows. I just threw those in there, but you can see that air leakage between the house and the garage, behind a fireplace, box framing, tubs and showers. How often do we spend the time to look at where those air leaks really are? And how about house-to-garage connections? I'm on the board of directors of the Co-Climate Housing Research Center in Fairbanks. And we've been doing some work there on studying how much air leakage is coming from the garage. As we improve the air tightness of the buildings, when we depressurize a building, where is some of that air leakage coming from? And I believe when a blower door test is done, we should check the pressure not only from the house to the outside, but the house to the garage, the house to the crawl space, and the house to the attic, so we can help a building industry define where their leaks are. If you said to a builder, your house is at 9 air changes, you didn't make it, the guy's going to go, okay, what am I supposed to do? Just like start caulking. What if you said to the guy, you know what, we did a house to pressure check and we were at 50 pascals to the outside. We threw the pressure gauge underneath the door in the garage, pulled the door closed, and found out we're only running 30 pascals to the garage. Do you have an air leakage problem to the garage? Would that help a builder know that there's a thing he can do somewhere between the house and the garage to see one of the problems? House to the crawl space, house to the attic will give you some information about where to start looking. But going through that exercise, well, that's why I said to Bruce about having testing be something that happens more continuously, is because people learn an amazing amount from testing houses. If you've ever been on a job site where they're doing some testing, I've been on lots of them where we set the target for the air tightness of the enclosure and invited the heating contract and the insulation contract and the builder all to sit there. And they're like, what are we looking for? We're looking for 3. Okay. We were looking for CFM actually, but that's easier for you guys because if we were saying we're looking for 800 CFM at 50. So the guys are all there, and you do the blower door testing, like, okay, how do we do? 650. Yay! Is that good? Did you want lower? You're like, yeah, lower's good. We did good, right? But all of a sudden they kind of started, so what does 650 CFM mean? You go, well, actually at a pressure that we've picked, we want a certain amount of flow that the building is going to accept. Not 3,000, but 400 CFM at 50. So taking a look at that pressure, having the industry know what they're doing. So I'd encourage you to invite people to tests. I was in Bend, Oregon, and I had a builder, and I said, how'd you do on your blower door test? What'd you get? He goes, 6. I go, 6 what? I don't know. I got a 6. Yeah, but what did 6 mean? I don't know. The guy said 6, and he left. Right? I think that's the biggest crime there, is we need to take the time to go, now here's what you did. This is what 6 means. And if you wanted to get to 4, this is what you would do. How much time would that take?
2.
Huh? I love that. There's always just one. There's just one. Yeah. So anyway, our house to garage connections. If you look at the diagonal wall with reference to the garage, how difficult is it going to be able to seal that diagonal wall against those eye joists? It's going to be pretty tough. So if you go in there, you got to put a piece and kind of stick it inside. And I don't know what the hell you're going to do, really. So is this a design problem? I think it's a design flaw, yeah. So if we look at thermal bypasses, I just want to show these are infrared pictures. Of course, the black showing up is cold air and infiltration. You can see the streaking lines depressurizing the space, and you can see the soft-fitted cabinet meeting up against the exterior wall of the garage. So you depressurize the space, and all of a sudden cold air pouring out of the garage starts to chill off that soffit, and you also look at that line there. In Minnesota, there was a time when we had the gas utility was seeing a lot of carbon monoxide monitors going off, and they went into houses to try to determine what was causing the problem. And it really wasn't so much as backdrafting and poor performing gas appliances as it was that they started a car in the garage, let it operate for 45 seconds. The garage went to about 80 parts per million of carbon monoxide. After about 40 minutes, the house was at 50 parts per million of carbon monoxide. So then they filled the garage with theatrical fogger, filled it with smoke. And they have a picture, the fellow with the utility was standing in the basement. It's bad, isn't it? Yeah. Matt's standing in the basement, and he's still got the camera coming on him, he's standing in the basement. And all of a sudden, he's slowly starting to disappear. Because the smoke in the garage is infiltrating along the bottom plate of the connection from the garage to the house. And also, they took a picture, they took a black mat, and they laid it on the door in front of the garage to house connection. And you could see the smoke pouring in out of the garage. That wasn't with exhaust fans running. So here's a house in the wintertime under stack effect, and sure enough, the air is being sucked out of the garage. Is there anything in the garage we don't want in the house? Everything in the garage you don't want in the house. We're only starting to learn how a car idle after it's been turned off, sitting in the garage with the door closed, is the only byproduct of that carbon monoxide. In fact, an initial startup is the highest rate of carbon monoxide. What else is coming off of that car when it's hot sitting in the garage? All kinds of volatiles, from plastics and carbon and a whole bunch of other stuff going on. So oils and solvents and stuff happening. Chimney penetrations and how we connect to the outside. This is using rigid barriers. How many times I see houses that look like this with a fireplace, the flue goes out the wall and they've got some kind of turbo plastic, the white fire-rated plastic. They tack that up there and it's all ripped and torn and pulled off the building. It needs to be a rigid barrier, insulated properly. Same thing behind bathtubs. When is that space going to get insulated? After the tub sets or before? And when should it get insulated versus when it is? And so many times I still go to houses and I look in that space behind the tub and see that they're hoping that a really little insulator, I mean a really little insulator, is going to crawl behind the tub in the shower and insulate that properly, which of course isn't going to happen. This is in Coeur d'Alene, Idaho. Is the tub going to get set and then somebody's going to have to crawl back there and air seal and insulate that cavity? So that's a design challenge. Providing blocking, this is a material that costs, that's thermoply, that's about $5 worth of material put behind the tub, and then they blew the thermal insulation. This is one of the largest builders in the nation. This was in Sacramento by D.R. Horton. They air sealed behind all of their tubs. Weren't required to, they just did it. Does this look like a fairly large hole? This is in an eightplex between the house and the garage. There's a big bunk of gypsum standing in the garage, so I get up on the top of it, and there's a small cavity in the garage corner, and I stand up on the top of it, and I take my camera, and I just flash so I can get that picture. I said to the builder, I go, that looks like a pretty big hole. And he goes, that's a big hole. Right? Now, who's going to seal this? The hole guy. Right? There's a hole guy. He drives around a big white van, and we got big black spots on it. He's a hole guy. He just takes care of holes. Because what guy did that? Who sat there and went, I can cut a great big hole between the house and the garage, and the hole guy will show up once I get deciding to run something through there? Isn't that interesting? Is the house-to-garage connection going to be a problem? This is their projects after we alerted them to these problems. Is that very complicated and expensive? All they did is decide the house-to-garage connection was important. They actually found the trade contractors saw drills that made round holes. Did you know they have those? Because you're supposed to use a sawzall to cut a square hole for a round pipe. That's the norm. But as soon as we got them a new bit, these guys totally figured this out. It's amazing. So the benefits of air sealing are pretty straightforward. A reduction of energy loss, about a third of the load of the building, in some cases more. Infiltration of harmful byproducts, which could be radon and soil gases and other things, as well as from the garage connections. Improved comfort, less drafts, and of course noise and dust. So we see one of the larger litigation issues that are happening now is issues of noise in multifamily projects. What are the ideas that somebody in one of those houses we saw today is going to spend $425,000 for a house and buy surround sound with TV? What's the chance? Pretty darn good. So the ideas of making noise become a big issue. It's one of the larger litigation issues that are happening. On preparing for insulation, this is what I see, you guys. These are unretouched photos. That's a 2x6 wall with 13 bats in it and not meeting, even filling the cavity. This is unacceptable, isn't it? So I had the insulator come over, and I said, come here. You can't do this. This isn't going to work. You can't do that. So I said, you've got to get the insulation so it fits side to side and touches all 6 surfaces. It's what it says in the manufacturer's instructions. It says, the insulation must touch all 6 surfaces, be free from voids and compressions. Is that what it says? So I said, that's what you're going to have to do. He said to the builder, well, if you want to do it like he said, it's going to cost you more. I'm like, really? So to install it right, I got to pay more, right? Where in your bid does it say really shitty work? I didn't see that. It must be, right? So I thought that was amazing, that if you want me to do it right, you have to pay more. And it's only because somebody called attention to it. And so if they were to do bats correctly, and I mean putting them in, splitting them properly, pulling them out so they fit the corners, touched all surfaces, would that now become more expensive labor-wise than blowing the insulation in? See, the whole point is, doing it right the first time is the thing that we would make an industry follow that approach. This is in Norman, Oklahoma. This is in California. How are we doing on the floor? Is the floor going to be uncomfortable for the space above this? And what's the answer going to be? Add a larger HVAC. When all the answer is to install the insulation properly. High density fiberglass can be put in well. I've seen them beautifully done. Put them in the cavity and carefully done. I'm just saying that in terms of time and labor, I think it's easier to blow it in. High density blown in fiberglass has been around for 24 years now, where they put up a nylon net and they blow the insulation behind the netting. Every major manufacturer of insulation has a blown in fiberglass product. High density blown in cellulose insulation can do a phenomenal job installed properly, making sure it's not too wet. Open cell and closed cell foams are now coming into the marketplace. We saw the flash and bad idea today in the Daily Project, or is it today? Break. I know, it's so close. I got the day part, didn't I? So the Daybreak, they had the flash and bat where they're using spray urethane on the roof assemblies and then filled the balance with a bat to meet the R value requirements. So is this going to improve the air tightness of buildings? Substantially. So if we have tighter enclosures at the same time, are we being equally careful with the combustion air and the exhaust capacity and the ventilation requirements? Do they go hand in hand? Hey, the builder just chose to do foam. Isn't that awesome? Yeah. But wait, time out. What else are we going to do? Nothing? Does that put that client at risk? And where do the codes fly? So proper insulation is ensuring that the R value works, the load calculations match, the thermal comfort is provided, the sound reduction occurs, energy savings is part of that, right? So I'm sorry about this. I thought I had one more in there. There. So are all those characteristics, are those fair expectations of somebody properly insulating a building? Yeah, I think that's what we just have to expect. So how do you achieve those expectations? Is this driven purely by code or by improvements in workmanship? Because isn't that important that they do the both? I'm a fan of codes. At the same time, I'm a fan of workmanship and craftsmanship. You can't codify workmanship. You have to really encourage good workmanship. So I think that those are something that all of us can help do. Are there anybody in this room that's a building official? Have you ever encouraged, in a positive way, a positive response? And gotten people to change? You can either go, forget it, this is bad and here's a red tag, or go, hey, you know what? Let me show you something. And you explain to them the proper approach and why. And say, in our community and in our climate, I think this would really be a good idea. You guys are the brilliant folks around. And helping someone through that process is essential. We have to do a better job, period. Now, on the advanced framing side, we saw that today, where we took the traditional methods of framing where the idea was, when in doubt, add another stud, right? So that where 4 is good, 5 would be better. How about 9, right? 12, right? And the one in the center, the guy said that they also needed to strap those 2-bys. Because they're about ready to fall apart, aren't they? Is that a micro lam or just a lot of wood? Right? These are unretouched photos. Is this a great big dumpster full of money? So this is sloppy workmanship. I personally think it's the guy that's framing the house is building a cabin somewhere. I think he's loading that sucker up, and he's also happened to be the garbage hauler. Hey, why don't I frame and haul the garbage? And you're like going, that's a brilliant idea, right? So but these are real photos from California, so you can see the housing there with all the open framing. Those are all ready to be clad. That's about as much shear as they get. It's amazing, into place. So now, I'm sorry about that. We had the opportunities in advanced framing, improved thermal insulation, lower energy bills, cost effective, reduction in waste, all real positive benefits. Green or not, I don't care what color it is. I don't care how many points they get. To me, this is just the right thing to do. We just got to build buildings with less material for more thermal insulation. So we have advanced framing, single top plates. We really look at the layouts of the wall cavities and the wall assemblies. We look at trying to stack that, reducing our overall load down to about 17 to 20% is a piece of cake to do. We can get down to 15, but 17 would be great. Some more numbers, just so you know, from the Building America project, showed framing cost reductions of about $1.05 a square foot by going to advanced framing. And then we saw the numbers showed calculations for energy savings of about 30% when they looked at advanced framing and the opportunities there. So getting to 50%, is that going to be easier than you think? You guys, it's a piece of cake. Getting to 50% is a piece of cake, as long as we do a bunch of things that are going to be opportunities. A little bit more here, a little bit less here. Should we help an industry know when to make trade-offs? What I see is people putting the same HVAC systems in thermally improved buildings. 400 square feet per ton, as a rule of thumb, is pretty good, isn't it? I'm like, you've got to be kidding me. Well, I've been doing that for 20 years. I know. You still suck at it, the sizing thing, right? Because if we don't look at the thermal improvement of buildings, the improvement of the windows, the improvement of the shell, and we're still using the same math, that's a problem. And people think that they are all running manual J's and all the load calcs. The guy's Xeroxing the thing, I think, and sending it through. It's just like I've been doing forever. I had one guy, this is the honest truth, he is one of the larger HVAC contractors in Lincoln, Nebraska. And I saw him, and he has a company called Bryant Heating and Air. And he's one of the biggest guys in town. And he had this blueprint. He used to wear this big black hat. He'd say this is a 3-ton hat. He'd stick that on the plan. If anything stuck out, he added a ton. You can't make that up, folks. I'm serious. So I looked at him, I go, well, that ought to work really good. What about orientation, windows? This has been working for me for years. I'm like, that's awesome. I want you to heat my house, right? On the moisture flow side, we also know that the ideas about the water and the way it comes, the moisture and the way it comes, ends up being in these mechanisms, and we're pretty sure about the flow mechanisms. We know the liquid flow in terms of gravity and rain, capillary flow in terms of material properties. Do you ever see things like wood stuck in the dirt? That's a good idea. But if you look around, if you drove around Portland or wherever you're all from, and you drive around the older houses, the communities that were built 40, 50 years ago, how far is the cladding and the trim away from grade? A lot more than it is now, right? Right now, homeowners don't want their friends to know they had to put in a foundation. Yeah, is that like concrete exposed? Yeah, we had to go with like a space. I don't know what the hell that's all about, right? So it seems pretty interesting that we saw cultured stone finishing in the dirt. Isn't that a bad plan? Now what are they saying about cultured stone? It needs to what? Have a space between the finished dirt and where it terminates. How come? Is it interesting that we expect brick to have an airspace and weep holes, but cultured stone, just because it's got a cool shape to it, is different. We call that lick and stick, right? That's what the trade calls it. You take the back, you glue it with mortar, and you stick it on the wall. You're like, that should be fine. Some people don't even put the mortar in because it looks cool. It's called the dry stack approach. I was in McCall, Idaho, and all the cultured stone is just kind of dry stacked, so that it has a lot more time for the water to stay in contact with the scratch coat, laying on a single layer of felt. So that we know that doesn't make any sense. On the air transportation side, pressure induced in terms of water flow, and we also look at vapor diffusion. How a building dries out. As we've looked at a better way of managing water vapor, how long ago has it been since in your marketplace, wherever you're from, they were still installing polyethylene on the inside of buildings and not managing the rest of the moisture flow? If you don't tape up the vapor retarder and the moisture gets through, how long will it stay in the wall cavity if there's polyethylene there? A long time? So in this marketplace in Portland, they're using PVAs, and that's kind of reducing the amount of vapor permeability. We just have to make sure that we understand that if the building leaks water, and we expect that wall cavity to somehow dry to the outside or to the inside, we design for that. And the best approach is to make sure that it doesn't leak. Draining buildings and making sure that all the water runs away from the building and off of the site, off the locations, running away from the building. How many of you guys saw at daybreak today the big piece of flashing at the bottom of the siding? It stuck out almost 2 inches beyond the siding. And I asked the guy, I said, why did you do that? He goes, well, because we have a vented rain screen, we expect larger volumes of water to run behind the cladding. So we put in a little piece of flashing that's pitched to the outside, so the water that runs behind the siding will be pushed away from the foundation. Well, that's a good idea. Isn't that a great idea? So there they got better rain management there. They flashed their details and penetrations. If you looked at how many of you guys saw how they had all the penetrations coming through the building and all the trim blocks around there, but there was no caulking at the top edge, and they had a little piece of flashing. The caulking was not on any of the top edges, and it had a little drip return to push the water out through the face. Have you noticed that? That's being done here pretty standard. This is here, it happens to be here in the Portland marketplace. This is built by one of the largest builders in the nation. Is that a good idea? Because I had to qualify, didn't I? Portland, and then design, and then a large production builder. And I asked the guys, I don't think you really want to do that, right? He goes, it's fine. We've been doing this in the Southwest for years. I go, oh, totally then. You should do that here. It's awesome. You didn't even, how long have you been here, you know? On the capillary flow side, this is south of here in Eugene. We can see capillary wicking coming up through masonry materials. In the Oregon marketplace, it's one of the few markets that I've been in where they actually install the brick on the footing, down in the ground. So they'll do their crawl spaces, build the walls, the foundation walls, and they'll start the brick at the bottom. The bottom course sits on the footing of the wall, not a brick ledge. So they pull the brick all the way out of the dirt, then they backfill up against it and wonder why they have some efflorescence. Is there a capillary break in that assembly? Not to interrupt any of the flow, so they've got all the salts and everything else dripping down the ledge on the top side. Water rains down, hits the belly band, and runs behind the brick. Does this look a little too close to the steps? Yeah. So you see how the siding, this is cement siding, and it's starting to get wet and get damp, and the siding manufacturers don't want to see this either. Do you think this column is a little too close to the concrete? I asked this builder, I said, don't you think that OSB shouldn't be sitting on the concrete? And he goes, it's okay, we'll be wrapping that column in stucco. Right? I go, oh, well then it's okay to do that because it's going to be fine, right? So does that need to be separated off? Could the bottom 1 foot band be a piece of treated plywood that's wrapped around the bottom band and still carried up off the concrete? Is that going to fail when it's wrapped in stucco? This is a guy in Massachusetts. He separates his porch columns off that finished concrete, and he pulls those little blocks out and leaves it alone. What is the building industry incredibly tempted to do right there? Oh, I got, oh God, I'm really good at this. I got this tip of the thing, and I just fill it right in there, and I take my thumb and you can walk away from the caulking gun, right? I tell builders, could you build a house without caulk? Could you? Could you do that, you think? Of course, of course. Yeah, we always had caulk. Yeah, the Romans had caulk. Yeah, there's super glue stuff, you know. If we look at caulking, I try to encourage builders. There's builders that tell me that they won't let caulking on the job site. They go, what caulking does, it creates laziness. When in doubt, we'll put a blob of something in there. And the flashing and the details come together, and when it's kind of a big spot, they go, just put a tube in there. I see it all the time. I see blobs of caulk in spaces. Air transported vapor in terms of just the general flow of air transportation. Now, we talked a little bit about that, so I kind of want to go past this quickly, but we talked about vapor transferring into wall cavities from pressure primarily and wind flow. Vapor diffusion in terms of an overall assembly, just to compare the last two. Through an air leakage, through a 4x8 sheet of gypsum with a 1-inch diameter hole in it, you can transport about 20 quarts of water over a winter season. And through an entire same sheet of gypsum, you can diffuse about 1/3 of a quart. We've often spent more time and interest in managing vapor diffusion, which is the smallest amount of vapor flow, than we have about managing the leakage of air, carrying with it moisture. So we spend more time worrying about the vapor diffusion retarders and the level at which we should look at the permeability of the cladding and materials on the inside and not thinking about air leakage. So air leakage and pressures are probably more important. So designing for performance is really building a building assembly that has the forgiveness of how you design that building. Gypsum board with semi-permeable latex paint, adhesive gasket, air sealing it, so the building has some level of forgiveness. Does that change by climate zones? Of course it does. In an extremely cold climate like Minnesota, northern Wisconsin, northern New York State, a lot of regions, we really call that, I think, zone 7 personally. But you guys are down to zone 6, right, Bruce? Yeah, I think 7 is, but where should draw the line? But 6 is pretty right on the edge. I think 5 is where they're at now. Or is that right? Is 5 class 2? 6. What do you think?
Lake Mille Lacs is 7.
Lake Mille Lacs is 7? So 6 then. Okay. So anything above 6 needs to do a much better job of water vapor diffusion control. But I still think in some cases we're going to see that a fairly low perm paint providing some forgiveness, but I'm not a big fan of polyethylene being at a perm rating of 0.06. I'd like to see something like a smart membrane, but that's coming. So applying the principles. This feisty projector. It says we need to protect our buildings as we're trying to design buildings, and so we're going to talk about draining the assembly really quick. Integration by who? Whose job is it to put these pieces together? Who's supposed to make sure that the flashing, the picture on the left is from Dallas, Texas, where they, for a long time, were putting paint on the OSB to act as the drainage plane, which I thought was amazing. I don't know how they're going to integrate that flashing, but that's finished, ready to be sited. The one in the center is in Colorado Springs. That's finished cladding, finished sheathing. They're going to put that, the flashing is done on the wall to roof interface and the step flashing, and as we speak, they're siding that with cement siding. No more integration. The other picture is just called sloppy, right? Integration, and we talked about this flashing connection at the belly bands and rims. This is Coeur d'Alene, Idaho. You can see this is about a $3 million house. Is that an acceptable visual? So the homeowner wants that bottom course replaced, but you'll have to replace the entire course so that it matches. What are the odds the next door neighbors are going to drive by because theirs looks the same and go, hey, mine looks just like that? What's the chance the guy coming back is going to do the same thing next time? I mean, it must have been like some bad wood. Right? Or caulk it. Who do you think made the hole? In the picture on the left, who do you think made that big gap on the left? Which trade contractor? Any idea who might have done this? We're pretty sure who did it, right? He left his calling card. It's called an electrical box, right? So this is being sited as we speak. I'm standing there talking to the siding contractor and I go, what are you doing? He's like, I'm trying to figure out how to patch that. What's he going to do? Use a slurry of OSB? Kind of goo it in there and patch that thing up? And how many people walked by that gap, do you think, during construction? Because after the electrician walked, how many people walked by and went like this? That's a big hole. You think? Because who's going to come fix that again?
The whole guy.
The whole guy. So if we look at this, it's somebody's responsibility. No one's quite sure. On the cultured stone interface, this happens to be a 3-year-old project. You can see that small shed roof on that chimney space. I was draining the water next to the cultured stone. The homeowner said, I want you to take the stone off so I can see what's behind the stone. As they pulled the stone off, you can see that if we leave this reservoir stored cladding laying on the OSB with a single layer of cellulosic black paper on it, it's going to cause some serious problems. Is that a pretty big problem after 3 years? Here's what you should look at if you can. Take a look at that fireplace connection termination right here. You see the fireplace termination, you can see the space underneath the fireplace termination. Do you think the top of that is properly flashed? It's actually just a kit that comes out from the fireplace guy. He screws on the exterior of the wall and you go, who's going to integrate those two? There's a guy that does that, right? Space behind brick. If we're going to do brick, we're going to make sure that there's a drainage plane behind brick. How long have we been putting in airspace behind brick? Pretty long time. Pretty long time. So I think airspaces behind cladding systems show in a very effective way that they dry faster. Even if you look at thermal insulation on the outside, it still shows there should be a minimum of 1/4 of an inch behind that material so we get effective draining out of that building. Weeps at the bottom, draining the water away. Do you think brick leaks?
Yes.
You sure? Well, absolutely it does. I've seen water in the backside of brick. We've taken off sections of wall just to test walls and pulled it away and watched in about 2 minutes. Liquid water begins to show up on the backside of the brick when you stand there with just a hose. This happens to be a 10-year-old building. This is in the central part of the U.S. Have you ever seen those water stains underneath windows? So here's that product being torn off the building, and you can see the result in the corner. Did somebody come back with a caulking gun? You see it? So I said, hey, the window's leaking. I'll be right back. Guy comes back. How did you do? 8 tubes. Like, right? Where did you put the caulk? If there's a gap, there's caulk in it, right? I was on a project in San Francisco where they used 80 tubes of caulk. Did the building leak worse afterwards? Yeah, because what they did is they sealed up all the potential escape routes that were currently working, right? So the idea is that caulking won't save you. This is the bay window assembly on the same house. Now, if you just think of the poor homeowner, right? They got this was all torn off. This was a $200,000 repair to tear off the stucco, replace the sheeting, replace the thermal insulation. In some cases, mold growing on the gypsum. So walking by, how many people do you think they're walking their dog like this? Hey, Bob, what you doing? The guy goes, oh, come on over here. They take a look at that. The guy goes home like what? Oh, shit. I got some of those stains on my house, right? So the builder had 8 of these. This is in San Antonio, Texas. Do you think it rains very much in San Antonio? Anybody from San Antonio here? It's pretty dry. I mean, it's not too bad, probably 20 inches of rain. These are what I call drive-bys. I shoot these all the time, but do you think it was interesting that the guy couldn't get the step flashing into the gutter? Yeah. Step flashing, even if they wriggled the flashing into the brick, he still couldn't at the very last minute turn it into the gutter. Are you going to see a failure increases at those places where the water runs past? If you look at the one on the left, you can see that the above gutter on the second floor had a downspout that they couldn't even get it to get in the gutter. That's a workmanship problem, isn't it? This is a pretty catastrophic, as you can see, as the roof line approaches more complex designs. So I got a piece of paper here. I just want to show you something. I don't know if you guys have had a chance. I'm sure you've seen Joe do this. I borrowed this from Joe. But it's the idea that if you look at roof designs, going from simple roofs to complex roofs, right? You've seen that? We used to have roofs like this, and now our roofs look like this, right? That's our new roof design. Yeah, there's a contest who can put the most dormers on a roof is a new design contest. So as we get incredibly complex buildings, is somebody going to have to make sure that that actually works? Because we are making buildings more complicated. A ranch-style house with a simple roof with nice overhangs works beautifully. That kind of roof, this doesn't work so good, does it? How much rain is falling off where two valleys dump into one spot? I thought today that it's interesting, at that roof at daybreak, they said the water is going to come out of them scuppers and shoot just right into the space down below with those little culverts. Has anybody been here when it rains? That stuff is going to come rocking off that roof like a big hose. And I just can't wait till somebody's standing down there going to knock somebody over with the water shooting out of that thing. So anyway, this is the wall-to-roof interface on the flashing connection there. And you can see that as they pulled that apart, the failure was right where that connection occurs. Too much water is concentrated. The ability to create a piece of kick flashing that throws the water off the building. Finally, we have the issues of installing windows. Because all windows leak, they most often leak in the corners where the water concentrates. When the windows get installed, they actually have a tendency to flex, especially in the vinyl sides, where they have great big openings. The California Energy Commission completed a study after 30 months that said hollow vinyl windows leak within 2 years. 20% of hollow vinyl windows will leak within the first 2 years. That's a pretty powerful ratio of leakage to a time frame, isn't it? So if they're going to expand and contract, what are the odds of that window expanding and contracting versus temperature variations? It's vinyl, right? When I was in Denver, the contractor had put the window in and had made it so tight around the assembly with brick on all surfaces that the window couldn't move. So when the window finally did move, it would bow to the inside and allow the window to do what? Leak when it rained. So finally they had kind of worn out the assembly. Nobody gave that window a design protocol for expansion and contraction. What are the odds that the fin of a window gets broken off? Yeah, I've seen guys put the windows in with an air nailer and a 16 penny. They walk through with poof. What's the chance of that maybe breaking a fin? Is this window going to get reordered? Yeah, that's the head flashing. Is it going to leak? That was in Alaska. These are wall assemblies with traditional stucco, 3 years old, 3 to 5 years old in that's actually in Woodbury, in a suburb of Minneapolis. You can see that the failure rate of the drainage plane in the window and the water intrusion is pretty significant, right? So do you think that now buildings in that marketplace, in that climate, need to have a rain screen behind traditional stucco? Does brick leak because the mortar leaks? So isn't stucco kind of a monolithic mortar that happens to be 3/4 of an inch thick that of course never cracks, right? I've heard contractors say, stucco doesn't crack much. All you guys know concrete, right? Concrete has two strategies, isn't it? Concrete that has cracked and concrete that's gonna crack, right? So that's just accepting the properties of the product, right? Once you go, okay, it's gonna crack, because people go, I don't really know if I like those saw cuts. You go like, that's fine, we can leave them out and then let the spider crack. I just want you to sign off that you like where it cracks anywhere it wants to. I think the line's fine, right? You just kind of explain the principle there. Windows, as I said, they're the connection points and how they come together. This is not adequate pan flashing. I asked the contractor, do you pan flash windows? Absolutely. I go, what about the corner? It's fine. Of course it's fine. It's not fine. This isn't fine either. Peel and stick products that get cut in the corner. This is a brilliant idea. The guy pan flashes like this, cuts the one critical spot, and then caulks the window on all 4 sides. That just doesn't work. Doesn't meet the laws of physics. Here's the guys that put the window in, do you think there's a small hole in the corner? Because the product doesn't flex. This is a retouched photo, right? You guys, you can't make that up. I'm serious. If you look at that, you kind of look at it and you go, how's the water's just going to jump off the flashing, past the gap, onto the fin? You know, that's California, of course. Do patio doors leak? Of course. People step on the threshold. Should patio doors be pan flashed and drained? That house in Denver that I was at had mushrooms growing. They had ruined $10,000 worth of hardwood floors in that house. Was the window company going to pay for the $10,000 floor? No. What did they say the problem was? The builder didn't do what? Flash it properly. So the window leaked. Now this is not the solution, right? This guy told me he uses 2 tubes per window. I'm like, that's awesome. That's amazing. That's the most I've ever heard used, right? He called that buttering. Yeah, I take the caulk on a putty knife and I just kind of butter it right into the side. I'm like, God, that's amazing. Yeah, it's good. So when that window leaks, it of course will continue to leak internally. So pan flashing again has been around for almost forever. We've got pan flashing in all different varieties. We just have to deal with it properly. Did anybody notice today, they just cut the house wraps and stuff. Do you notice today how they pan flash the windows? They had those little corners, those little rubber corners, and they put those in and they had the house wrap laying over the top. They had the windows sitting in the openings and it wasn't caulked on the bottom. The only thing that they were kind of missing was what? What should they do to the sills? Tilt it where? Out. You know, you think that's obvious. I've asked, which way should it tilt? Out? Yes, good. That's awesome. You know? There shouldn't be much of a delay there, at least in my opinion. But there should be. That's one of those things you just got it. So pan flashing, that's a product called Flex Wrap, but it's really kind of cool. DuPont has it. There's other products on the market that also do that. You caulk it on 3 sides. You then insert the window into the opening. You place the flashing on the sides in that order, and then of course on the top. And then you lay the paper down. Shouldn't every window installed be installed so that it's flashed properly, integrated and layered, and then designed so that when it leaks, it drains to the outside? Should that be done just across the board? And would that make an enormous impact on the fact that if we have 20% of the wall area is glazing, we should probably plan for its leaks? Sloping the sills is a couple approaches that I've used. This is one using a piece of beveled cedar. I've got another one where the guys use 2 2x4s on the bottom sill. After the window is set, they'll end up taking a small claw of hammer or a little wedge bar, put it between the two, and then just drive a cedar shim. You only need about 1/8 of an inch pitch on that window to make sure you're encouraging it to the outside. There's lots of ways of doing that. I had a builder said to me, he goes, well, I'll just tell my framing guys to cut a small angle on that cripple before they put in the sill. I'm like, okay. You think guys can do that? Framer goes, I can do that in a second. All you got to do is ask, right? Could you do that? Sure. Do they ever bevel the corners and walls and bay window assemblies? These guys can do that just like that. It's just about asking. This is what we need to do. You can see the beveled cedar went in, the flashing goes on, the flashing gets put in the opening, and then the window gets installed. So, and you can just see now there's the whole windows pan flashing ready to go. Are these products readily available in the market? Go to every lumber yard in this town and find that product tomorrow. The guy goes, that's expensive. It's $2 a foot. I go, okay, what's your option? Not to do it. Okay, let's do that. See, is the basis no money again? Should the basis be a non-flashed window? The guy goes, pan flashing or not? Oh, that's going to be expensive. What was your alternative? Pan flashing with this or pan flashing with that? That's where you make your cost, your basis. A flashing system that works is what you establish as basis. Here's the inside. They just used a piece of backer rod. They shoved a piece of backer rod on the inside into that cavity, kind of the way they do commercial windows. Shove the backer rod around the bottom on the inside, put a little layer of caulk to act as a back dam, or they could use backer rod all the way around, which is what they did here. They backer rod all the way. I want to show you this as an example of a technique, and this is something I just worked on developing, but I want you to see this. Just take it takes 1 minute to do this, to see this, but tell me if this would be a helpful methodology for helping an industry figure out how to properly install windows. Do you guys have any problem with the language on this one? Now I have that detail on my iPhone. Wouldn't that be cool? Hope we just showed trade contract. Hey, you know what? I email this to you tomorrow, and then you can do that just like that on the job site. Wouldn't that be something? Is that doable? Do we have the technology for that? Did you guys see that video that they ran today about that high rise? Did that at the beginning look like it was real? And did it only freak you out when the helicopter flew between the railing and that light pole? That's when I had an idea. It might have been computer-generated graphics. I'm like, dude, that's a little helicopter, you know? But all of a sudden you can see the people walking, you're like, I think this might be fake. But I think it's pretty impressive that we have the technology to create a method for communicating that effectively. This happens to be a builder in Denver, Colorado. That's in the Stapleton development. All the house wrap is put on. The windows are pan flashed and drained. Someone comes around to make sure all the penetrations are flashed properly. This is just a pre-siding installation inspection. I think there's 3 times that we have to very carefully look at a building. When prior to insulating, making sure that we've done a great job of air sealing, right? Prior to the drywall going on, it's kind of that sequence. Making sure the insulation is done properly and it's air sealed. Prior to putting the roof on is when we should look to see and make sure the flashing at the roof assemblies are done properly. I walk roofs all the time. On Friday I was in Denver and I'm walking on the scaffolding 3 floors up, jump onto the roof and I see reverse flashing. So I got the builder, come here, you got to just see something. What do you think of that? He goes, it's backwards. I go, I know, but when should you check that? He goes, I just got a new roofer. Okay, when you hire a new roofer, you might want to check to see if he knows what you expect. Would that wall have gotten fixed? Would it have leaked? And the idea of taking a look isn't that difficult. And then lastly, I think we should do an inspection of the exterior of the building, not a code inspection. The builder should do these inspections himself. I think they should really be caring about the craftsmanship prior to cladding the building. So venting the cladding is the final thing we're seeing in terms of rain management. Vented rain screens. This happens to be here in Portland. One of the larger builders was putting up furring strips on the side of the building. Use a piece of treated plywood. The only problem is you need stainless fasteners. An insect screen at the bottom to make sure you keep the bugs out of that cavity. And then they put the cladding over the top. This is a cement cladding going over the top of vented rain screens here in Portland. There's another product called Eldorado Battens, invented by a company out of Sacramento. It's just a fluted plastic batten. An 8-foot piece runs $2. They put that on the wall, and now it allows for ventilation, cross ventilation back and forth. You can put it horizontally, vertically, and put the cladding over the top. The builder in Denver, Colorado is using these. He's putting up a piece of felt, and he tacks his expanded metal lath over the top of that, puts his scratch coat on, and then he attaches his sculptured stone or the rest of his stucco to provide a vented rain screen behind his buildings. This shows the siding and the insect screen being placed for that cavity. That's kind of what you saw today. There's another product on the market called Home Slicker. It's been around now for almost 10 years. It's probably about a little bit more than 1/8 of an inch, and it comes on a roll. They roll that out on the building. It looks like kind of a stretched out Brillo pad. You put the cladding and the siding over the top of that. It allows drainage to occur behind the cladding. You put a piece of trim over the top. In this marketplace, they still use spruce as a piece of trim. That should be against the law, right? And that's their cost basis. I said, guys, spruce is going to warp out and twist out and fail. And that guy goes, well, yeah, but going to cedar is pretty expensive. Should the spruce not even be an option? You shouldn't be able to put unprimed spruce on a building. I'm sorry, that's called interior trim. You don't put that around the outside of the windows. The common holes that get missed, we talked about all these penetrations and people making holes with hammers and pretty big deals. This is, again, an under-retouched photo. This was in California. What tool was the contractor using to make this hole? That's serious. It was amazing. You would think. It should have been his head, the knucklehead. He was coming up with a sledgehammer, kablamo. I said, you've got to be kidding me. You've got a drill, right? Yeah, it's in the truck. Well, you might want to go get that. Well, how come? I do this all the time. So you get my point? That was the point I made earlier. We reinforce bad behavior. If I was a builder and I saw that one time, what would you do? Hey, buddy, guess what you get to do today? Buy a whole new sheet of sheathing. You get to take that piece off, put the 400 nails per sheet back. Isn't that what we require now? Put 400 per sheet? I swear there's more nails than there is material. So you pull that piece off, make him get a drill the hole correctly and put it back on. Is that going to motivate him next time not to do that? And that's all that reinforced behavior is. The guy goes, I don't buy sheathing, then you don't work for me. That's how you reinforce good behavior. Penetrations like this, I don't know what the guy is thinking, but somebody's going to come back with a sewing kit and patch the Tyvek, right? They're going to, yeah, my mom will stop over and sew that up, I swear. This is another example. This is called just completely irresponsible. This is irresponsible behavior for whoever did that. What would it have taken for the guy to take a small knife and cut a hole, right? So these are workmanship and craftsmanship issues. It's easy to provide flashing and counter flash the piece. There's products on the market like that called Quick Flash. This guy that invented this for 19 years repaired problems and flashing failures in buildings. And he invented a little product like that. It's got this little neoprene boot. He's got like 16 or 17 sizes. And those boots cost between $6 and $7. Now, can you imagine the plumbing contractor going up on the roof, takes his heel, smashes his heel through the roof deck, runs the vent pipe and wraps a little felt around it? How would that go? And you know what the problem is? How does the roof boot get flashed? How do they flash those penetrations? with a boot that goes over the top with a little collar on it, and they slide that over the boot. So that's necessary in roofs. Don't worry about it in walls. Doesn't that seem bizarre? But the catch is it's cause and effect. When we see when a roof leaks, how soon do you see the leak? Right away. It's an immediate motivation. You look up and you go, roof's leaking, right? So on the roof, it's also ventilated, isn't it? And you ever see us try to minimize penetrations in the roof anyway? Does the industry try to minimize penetrations? Of course. So you minimize penetrations. There's soffit venting and ridge venting just in case you get a little bit of moisture in there to remove some of the built-up heat. But now you have a building assembly that's got minimized holes. Penetrations are properly flashed, and it's ventilated for forgiveness. Now I'm going to go like this. Now what? How many holes in the wall? As many as possible, right? Right? Is it ventilated for forgiveness? No. When does the homeowner or the client see the leak? When it's too late. Yeah, when it's too late. Usually when there's fairly significant damage. So the motivation has to be that the walls leak, so does the rest of it. Finally, in the testing for performance aspects, Bruce talked about the pressure testing of ducts, the blower door testing of houses, and the using of infrared cameras. Infrared cameras now are in the range of between $7,000 and $8,000 for an infrared camera, not $25,000 anymore. I was one of the guys that bought the one for $25,000. Anybody want to buy a really nice infrared camera? But those tools for testing, all of you, of course, have been on job sites and been in projects where they use those tools, right? And when you've been out there and you've seen those tools used, is it a remarkable experience? You ever looked at an infrared camera and looked at a wall and seen how poorly insulation can perform? And you see the studs are about this wide. And that just shows you the lack of insulation contact at that exterior wall cavity. So our industry, the building industry, is changing, right? This is from Seth Godin's website. If you just look at this detail, that's unretouched. So the guy that driving the paint striping truck was doing his job, and he's not the guy that's supposed to move the stick, is he? There's a stick removing guy who's supposed to go ahead. So you're driving the paint truck and you're like, whoa, right? What are the odds that somebody's going to driving down that road going to follow the line, you know? If you've ever been to Hawaii, I was in Hawaii, I was on Kauai, and I was looking at them painting the road, and that line went like this. If you just looked all the way down the road, but it's okay, man, right? They have rum in Hawaii. So there's certain places it really doesn't matter. And I looked at that and I was like, in Hawaii it doesn't matter. I think in most areas it does. This is a builder in Pennsylvania, and he's in Philadelphia. Actually, his name is Don Pulig. What a phenomenal individual. Tremendous builder. Him and his brother building houses for 30 years, mostly in the higher upper bracket ranges. What a phenomenal individual. And in order to make sure he's doing his houses right, he decided to build something quite revolutionary. It's called a mock-up. How revolutionary is that? Not very revolutionary, is it? He just built wall assemblies, and that's a stucco contractor, and he goes, guess what? This is what we're going to do. Put on our house wrap, put our flashing properly, put that home slicker on. We're then going to put a piece of black paper over the top, then put the lath on, and then put the stucco over the top, okay? That picture's 5 years old. He put that on his job sites and told everybody, that's how we do it here. Then everybody walked over and they'd go, okay. Okay, right? So they look back, and if you do it wrong, he said, if it doesn't look like that, you get to do it again. Right? That's a pretty good motivator. So why don't you make that and that look the same? Okay. Do I need to even speak the same language to get those two right? So we're going to bridge these language barriers, not by just translating things to a different language. Is it possible that somebody that speaks a different language is also incapable of reading? Is that possible? Are there people that live in this country that speak perfect English but can't read? It's just a fact. Are there people that speak foreign languages that can't read? So suddenly we think we're doing everybody a favor by translating the language. What we really have to do is find a way to communicate effectively through the idea of using demonstrations. Finally, these are some pictures. This is McStain in Denver, Colorado. For the last 25 years, I've been building green houses. And what they've really been doing is just building great houses. And when the green came along, he goes, well, we already insulate incredibly well. We pressure test and blower door test and our ducts in our houses. We make sure that our houses consume to 30% more efficient than the current state building code. Is that a motivation for marketing? Isn't that cool? Do you think people are at all interested in that kind of information? What do you think? Some people say no. I'm like, some people don't care, do they? Do some people care? Of course. Some people care, some don't. It's okay. That's called America. You get to choose. It's a great thing. You get to pick. This is in Denver also. Those are photovoltaics with a hot water system. That's an 8 kW PV system on that house. I was there the other day, and it was about 11 o'clock in the morning. It was at about 6 kW. It's pretty cool. Do people like that on their house, having that system there? Do you think? Yeah. The people that have it, do you think they tell their friends about it? Yeah. Why don't you come over to my house? I got solar. We can cook on the patio free. When this is a project, this happens to be in February in Denver, and everybody's got coats on, it's snowing. The builder decides to have an open house 3 weeks earlier, and in Denver, you never know. It can be 60 and it can be snowing all in the same week. It's an interesting climate. And so everybody came to this demonstration house, 250 people on a Saturday, 200 people on a Sunday. Bad weather, everybody came into Stapleton, in Denver. And they showed up and they were standing in the basement. That's Dave Schrock in the back. He's the HVAC distribution guy that owns the distributorship there, showing the photovoltaics and the tankless water heaters and the heat pump and the whole systems. And people were staying downstairs and they were listening to him talk about stuff. It was really cool. He got done. He goes, I've never had so many people stay so long. Was the builder excited about that? It's a lag time of people inside of houses. If they walk in, they go, what'd you think of the house? It was okay. I just didn't like that blue couch. It doesn't come with a couch, right? And the problem with that is that we don't communicate effectively to buyers what it is they're looking for. We let them walk by themselves. So people walk through a model home and you go, so what do you think? They go, it's pretty nice. Good. You want to buy one? Isn't that interesting? You don't walk people through. Vernon McCown in Oklahoma, in Norman, he's one of the finest builders I think I've had the pleasure to meet, building in a really interesting price point, probably between $185,000 and $300,000. He makes his sales agents walk every single buyer through the house, and he has to show them one feature and one benefit in every room that they visit. He has to visit at least 3 rooms before he lets the homeowner go on their own. This is about really communicating effectively with people and finding out what they want. This happens to be the energy costs in dollars of that particular house in Denver. You can see the IACC Code House. You can see the Harvard Standard House. Harvard Communities is the name of the builder. And the Near Zero Energy House is the bottom one in purple. They are doing a remarkable job. He's 2006, he built 28 houses. 2007, he built 26 houses. Last year, he built 25 houses. He's doing okay. And how is he selling in terms of communicating? In a down market, he's just communicating effectively with people that they think that that's an option. So for additional information, do any of you guys read Journal Light Construction, Fine Home Building, Energy Star, Building America, Green Building Advisor? These are all some websites. Was it okay that I put PNNL on there? Yeah. I know who paid for my hotel room. Yeah. But these guys are cool. There's a lot of information out there that you should be accessing. There's ICC. There's a whole bunch of other places that have tremendous information available. If you don't have any copies of the Builder's Guides, how many of you guys have copies of this? This is written by Joe Stiebert. Joe's books, beautifully done. They've been in publication for a long time. There's one for each climate zone, 400 to 500 pages, 250 to 300 illustrations, and they're available at the EBA bookstore, at the buildingscience.com website. But if you don't have one, you have to get one. You just need to know how the details from design all the way through completion are done. There's a ventilation guide written by Armin Rudd, an insulating guide written by Chris Mathis, and a water management guide was done by Joe. So if you look at those kind of details, those little guides on the far right, they cost about 18 bucks. And I've had a building community that I worked with in Jackson, Wyoming, where they actually made the contractors buy one of those, right? And the city could actually buy a few, and with a building permit, you paid for the permit and you got a guidebook that says this is what you should do. Just a suggestion. It's called a best practices guide, and we just recommend that you follow this approach. Is that a way of doing it, motivating a market? If we did that early, when Bruce started doing the things in Minnesota about 1992, we did what was called the ECAP project, Early Code Advancement Project. Myself and Pat Hellman would go to all 20 regions of the HBAs around the state and do a one-day training course on building science and building physics. That's it. So then when the code came out in 1994, everybody was like, okay, fine. Because we explained why. It wasn't the government doing this to me. It was just this evolution of, well, if this is the way the physics works, this is probably how I should build. And it was a little less of this. After the meeting today, I'm going to be meeting John Chandler from the state HBA. He called me this afternoon, and he goes, somebody told me that you were here. He says, I'd like to sit down and figure out how we're going to get our builders properly trained to make sure our buildings work effectively. There you go. That's called a partnership between industry and government. We're going to find a way to do that. And I think that there's a better way to do that. Bruce has found that in Minnesota, he's got the HBA and him working together on code changes. And they go, this is what we're going to do. What do you guys think? Oh, no. Okay. And Bruce, in his own way, if you know Bruce well enough, he's able to guide people around and they don't even know where they went, you know? So they kind of get done and they go, how the hell do we get here? I don't know. Bruce took us on a trip somehow. I don't know. He's put something in the coffee. I don't know. He's able to do that. There's a series of CDs on building science that you can get, and those are through Taunton Press. But I want you to leave this last thought before we talk about some questions. John Ruskin said in 1819, this is the inside cover of Joe's book, it says, when we build, let us think that we build forever. Let it not be for present delight or present use alone, but let it be such work our descendants will thank us for. See, the motivation for what we're doing and why we're doing what we're doing isn't about us. It's about our responsibility to each other and to our children and their children. You guys think sometimes that's this big sob story about polar bears and ice cap melts. This is about really understanding what's going on. What is happening to our environment in terms of the fact that we've gone from 3 billion to 6 billion people in 50 years? Have we charting new territory? We don't know. Everybody wants to point a finger and say somebody doesn't get it, but just like neither do we. But something's going on. And we probably realize that we have to do something different. Does the consumption of energy and the saving and dealing with carbon really make a difference? Do we believe that? Do you guys believe that'll make a difference? We try to reduce some of our carbon footprint, but more importantly, build buildings that use less energy for this country. This country, the United States, should be in a much better position than it is in terms of its dependence on oil from other places, from energy from other places. As a country, could we have done a better job since the first oil embargo till now? Amory Lovin said if we just would have left the requirements that we put in place in 1974, we currently would not be importing any fuel, any oil from the Middle East as we speak. Wouldn't that have been awesome? And we already know that's true. We can go back and do the math. So we go, fair enough. We didn't do it right that time. Now we're going to do it right. And what's that going to look like? We're just going to slowly and steadily, or preferably a little faster, improve the way that we use energy, the way that we produce carbon, the way we produce waste, and the way we use resources. And how we're going to be motivated to do that is all, again, about choice. We can either force people to do things or educate them about making good decisions. And that's what we're trying to do today. You guys are now people that are going to go out into your marketplace after the last 3 days, learning everything you've learned, and begin the process of transferring this knowledge and information to the next batch of people that weren't here. So that is your job now. Starting today, you take everything you've learned and everything you've seen and you start talking about it. This is where things are going. This is what we're seeing happening. And start moving the message across, because it isn't something that you have to convince people of. We just have to explain what's going on. Use that term, guided discovery. When you explain things along the line, when someone gets to the end, you go, so what do you think? You probably should do that. All right, let's go. See, isn't that fair enough? If we take that approach, then this code stuff doesn't seem so looming. You say, oh, what's going to happen in 2012? Oh, it's going to be bad. People are going to be pissed, right? So we take that approach, and then everybody's afraid to stand up and go, hey, this is what it should be. So that's what I get to do, because I have the microphone. And then you guys get to help make sure that that happens. So go forth and change the way we build buildings, because it's not that hard, really. We just have to say, okay, and then it happens. So that's all I have for you. Do you have any questions at all?
Yeah.
I think they have some mics around, so we could ask questions for a little bit. Dear, how much time do we have? How much time did I leave? Oh, yeah, right. You had her daughter step on her toe. What time is it about? Perfect. We have some time, so if you guys wouldn't mind, it'd be worth asking some questions. So any questions? Yeah. Yes, sir. Please, yeah.
Say, all this stuff is well and good, but as you know, for each $1,000 of cost you add to a house, you eliminate 213,000 people from the housing market. And furthermore, you eliminate many products from the marketplace that reduce the choices available to housing consumers. So, I mean, while this is all well and good, how do you address the question of these onerous costs driving up housing costs through the roof and just putting everybody out of business? I mean, how can you do this?
He's full of shit, isn't he? Yeah. First I thought he was at NHB, and I'm like, no, that's a bunch of BS what he just said. I can't believe it. No, but he is. It's very important, because what he just said is what we hear, isn't it? So what are we going to do about that? Because is what he said, in the way that he said it, is it wrong? What we have to do is find a way to prove the fact that at $6 a thousand for borrowing money, if you add $3,000 to the price of the house, that adds $18 to the mortgage payment. For $3,000, can you get $18 in savings? So does that then provide the fact in Canada, when they do qualification ratios, it's principal, interest, tax, and energy. Not principal, interest, tax, and insurance. Nice job, insurance lobby. Yeah, right? You get that in the qualification ratio. I'm like, that's called good lobbying, right? So who's the lobbyist for energy conservation in terms of making sure that, shouldn't the qualification ratio for a loan, principal, interest, tax, and energy? Because isn't that your big variable? So if you found a way to say, you know what, actually, because the house is going to be thermally efficient, you'll be reducing your overall payments per month and your expense per month by $30. We'd be glad to lend you $18 more to save $30. The next problem we have is appraisers. Appraisers look at a house and they look at this project and you did a really nice job and they go, I'm sorry, I have to do a comp on that. It doesn't qualify for any of the comps. So all those improvements you did, tough. Right? So the industry is looking currently here in Oregon is a group called Earth Advantage, and they've been working with the Department of Energy to really come up with a better ratio of saying, they're showing that the houses that are built better and more performance enhancements and green and stuff like that are selling faster. There's a high absorption rate in communities that are doing that. Houses actually go up for sale less often, which is quite interesting because people really like the comfort of their house. So taking that data and now trying to roll that into the appraisal community. So now when I do my comps, I go, the comps are the house is worth $200,000. But because it's rated or it's got this score to it, it gets a 1.25 multiplier on its comp. Wouldn't that be a cool way to do that? So the guy goes on the comp, he goes, okay, your house is worth $325. You go, awesome. So we have those values. Taking people out of the borrowing pool, here's what's interesting. In Habitat for Humanity, they've been working on projects, and Habitat for originally was saying, all we got to do is get people into houses. That's the most important thing, get a roof over their head. That turned into a really bad idea. Do you think Habitat gets into enormous trouble when their buildings leak and they have really serious performance problems? Does Habitat get in trouble for that? Oh, absolutely they do. Because the people that bought the house, even at a lower price, still bought the house. So now they expect something to happen. Have they ever had any litigation issues for water intrusion? Absolutely. Guess what they've decided to do? If any of you know the wonderful man who lives up in Seattle, his name is Marty Koistra, one of the really fine people with Habitat. I got a chance to work with Marty in his very early days as executive director of the Habitat operations in South Dakota. He then moved to Georgia, where he was there for quite a while. And up in Seattle, he's building these absolutely amazing Habitat houses. What he's doing right now is he's flashing them properly, all the drainage planes, insulation, air sealing, ducts in conditioned space, designing them right. He goes, you know what? I'm whooping the builder across the street, and it's not like we're doing this for free. Now he's got a little bit of labor benefits, doesn't he? Yeah, some of his labor is a little cheaper. But Marty's really done a phenomenal job of saying, I'm demonstrating that if we can build Habitat houses incredibly well, it's just the way we have to move forward. So that means that people that have a lower income in many cases have issues with upper respiratory. We see that to be pretty solid in the data from the American Lung Association. We've got to be careful with indoor air quality. So we've got to build really great buildings with ventilation for occupancy and filtration for fresh air for people that have upper respiratory ailment problems. Also, in the people that have lower incomes really need to make sure their energy bills are affordable. So if we build energy efficient buildings that are incredibly healthy and durable, isn't that something that everybody is supposed to get? In England, every contractor that builds buildings in England, commercial or residential, has to build 20% of their buildings have to be social housing. The way they changed the market in England, in London especially, is what they said is everybody that builds social housing has to exceed the performance criteria of the R2000 program in Canada. So now they were building social housing that whooped the stuff they were building for non-social housing. So guess what that did to the marketplace in a non-codified marketplace? You're like going, I suppose we should build the stuff we build for everybody else, at least at the level of social housing. Pretty interesting motivation, right? So trying to bring up that overall bottom, and part of the challenges right now within AHB and that community is really what they want is nothing to change. So how do you deal with somebody that wants nothing to change?
Tell us.
I'm trying, man. Have you ever seen, I saw this really cool little cartoon, and it showed a guy, there's all these guys on horses with arrows in their back, and the guy's standing there and he's talking to this guy with a Gatling gun, and the guy goes, can't you see we're busy, we're about to fight a war, right? So the idea is that does the technology provide us with a way to change cost? What we have to do is demonstrate. How many of us have done enough case studies that demonstrate the efficiency, performance, and true cost of buildings. Does that exist out there?
No.
Does it? Somebody else in this room, tell me, does it exist? He just wants to be, no! Somebody get him a beer, please. He'll just soften him up a little bit. Is there case studies in the marketplace demonstrating high-performance houses that are affordable to operate, that cost less to operate and purchase than a conventionally built house? Does that data exist? Yes, it does. So what we have to do is make sure that everybody who said yes in this room, bomb the guy's email. Just fill his email with that stuff, because he's right. He needs that. He's being really honest about the fact that if we're not able to clearly communicate these obstacles, then we're going to be just in the situation we're in. We're always defending better buildings. Like, yeah, but it's good for the planet. You should say, no, it's the only way you can build. And my problem is the basis is a bad place. We've accepted even less than code as basis. And that's what's difficult. How do you change less than code as basis? Have you ever walked into projects, you guys, and seen houses that don't even meet minimum code? Because people think code's the pinnacle. I made it to code. Good job. Right? Have any of you that do look at buildings, are you ever excited when you see a building that exceeds minimum performance criteria? That's a pretty good thing. Then how do we demonstrate that better in the marketplace? And all of this is going to take a pretty interesting effort. But I'm doing my best. I talk to 10,000 builders a year. I'm working on it. How many do you speak to a year? See, get going. See, just I was motivated. That's what I'm saying. But we got to say it in all the positive ways. This isn't something that you can't do. This is something you can do. I remember somebody said this thing about a teacher. She said all of her students were sitting around saying, I can't do this. I'm too heavy. I'm too fat. I'm too slow. I can't do this. She said, I've had enough. She said, I want everybody to write a list on a piece of paper of everything that you can't do. So they put this list together. She had a shoebox, filled the shoebox full of all this stuff, marched all the kids out on the playground and buried the box in the dirt. She goes, there are now no more I can'ts. There's only I can. And when the kids say, I can't do that, oh, no, we buried the I can'ts. See, all I'm trying to say is this is an issue of attitude. I keep saying it's about attitude. As soon as you change that attitude to say it's possible, it happens. As soon as you say it can't happen, it won't. I believe it's that simple. Nothing happens unless you choose to make it happen. Remember the quote from Margaret Mead? A small group of thoughtful people could change the world, and in fact, it is the only thing that has. So, have you ever thinking about it across this world, how many one person has made a substantial difference in changing the entire planet by one person wanting to make a difference? So be that one person. And you got a ton of friends to help you do it. Now, who else? Anybody else? That was a simple answer, huh? Look at that, huh?
Mark?
You guys are like, I'm not answering another damn
Mark,
question.
you
Craig?
partly answered this, but I want to come back and defend the builders. I think it's not good. They're neither good nor bad. They're not uniformly bad. It's really nice to get in a room and find the person who's not in the room and pick on them. Lately, the builders are doing better. And in the code arena, I don't think it's primarily the builders. I think it's the product makers going to war with each other that are the primary impediment. But my question to you is, you and a handful of people are pretty effective at communicating. I think the audience you communicate to most importantly is not this audience. It's the builder audience.
Yeah.
You and a handful of people are effective at doing that. Why are you so effective?
No, I think I also want to correct something you said first. You said I'm hard on builders. I'm not hard on builders. Builders are doing whatever they think they should be doing. And they repeat today what they did yesterday. So all we have to do is find a way to change that. But I think builders are actually pretty remarkable individuals. They're the people I like the most. How could there be a better career than building houses? What a phenomenal thing to do. You put people in homes. What a great gift to anybody. What an amazing legacy you get to leave. You build a home that families, 5, 6, 7 families will get raised in this gift you've given other people, a house. What an amazing thing to have. What does a computer programmer get to say he did? What'd you do today? I wrote some really good code. I was like moving ones and zeros all day long, right? But the building industry gets to say, actually, I did that. Have anybody ever seen a house that was built, or that builders that build houses? I always tell this all the time. When you build a house, do you ever go and show your friends? Yeah, all the time. I did that. I did all of those. When you go on vacation, do you ever look at houses? Yeah, you go to get a cup of coffee, and 2 hours later you come back, right? You're crawling under the fence, crawling through a house, and say, oh, that's what they do here. That's pretty cool, right? Where have you been? The line was long, really long, right? So I find myself looking at houses. That's what we do. Isn't that cool? To be a part of an industry that you love that much? So, Craig, I love the building industry. The problem is that I think that the art of communicating effectively comes from everybody. Material manufacturers in one way do create problems. They create misinformation. One company says, I saw the guys that did spray foam. Their ad said, spray the foam in the wall cavities, you no longer need a house wrap. That's what they had in their ad. I called them up and I go, you guys, that is flat out irresponsible. They go, well, yeah, but if you spray the foam in the wall, you no longer need a house wrap. For air infiltration, what about for water management? That's not our responsibility. You just made it your responsibility in that ad. You just said no longer need a house wrap. So they missed the whole point on the physics side. You could now say, improve the energy efficiency and reduce drafts in the house. But don't tell them you don't need a house wrap. That is really stupid, very irresponsible. And I'm personally fighting with a few manufacturers right now that say all you have to do is tape the seams on the sheathing. I'm having a little hard time with that. I'm trying to figure out how you tape sheathing to make it weatherproof. How do you get the window fin on the head flashing, wriggle it into the foam, wriggle it into the sheathing? I was in Atlanta last Monday with one of the largest manufacturers of turbo super sheathing, zip wall and zip roof. That says now you put the OSB on the outside, we've got this really cool coating, and as long as you do a great job of taping all the seams and joints with our super tape, it's pretty cool stuff, it's acrylic tape. You tape the head flashing, all the penetrations and everything with tape, and then you clad right over the building. No longer a need for house wrap. So I says, well, how do you get that head flashing in there? Should you wriggle it? And take a saw and cut a small wriglet into the sheathing and then shove the flashing into there and then tape over the top? Because I'm a big fan of the fact that I think sealants will fail. But it's okay if everything's layered and flashed that it can drain out. But the manufacturer is now saying, how many of you guys are comfortable putting on OSB? It would be comfortable putting OSB on a roof and then no building paper and shingle right on top of the OSB. Everybody okay with that? They go, as long as you tape all the joints and seams. I go, what about a valley? So you have valley flashing running down the valley, and you want me to tape the valley. You go, yeah, you can actually take a 4-inch tape and tape the valley. I'm like going, I don't like that. Right? What's wrong with valley flashing? That's expensive, isn't it? No. Why wouldn't you put valley flashing in and then properly do it? If you've got such turbo product and really good seams, why wouldn't you put a layer of felt as a layer of forgiveness and then let the layer underneath be really super turbo and it would last longer? That'd be awesome, wouldn't it? Well, we're trying to get into a marketplace so that sheathing's a little more expensive. So if we take the house wrap out of the equation, our product looks better in terms of price. I'm like, well, okay, I guess you can do that. They've got some pretty cool stuff that they did to show that that product doesn't let water through the OSB. But I'm really worried about the seams, the joints, and the connections. If the roof looks like this, how do you feel about tape? This would freak me out if you tape this. But hey, it's doable, and it's acceptable, and they can do it. So I think that the manufacturers have to make sure that they're talking with the same nomenclature. Some of these guys like to take off a couple of units. Oh yeah, degree days, it doesn't really matter for us. Or yeah, you can get rid of the Fahrenheit on the calculation, everything's okay. People like to remove units when it works for them. But I don't think you can remove units, do you? Can you? Oh, there's enough engineers in this room to, you could throw you guys at people. It's amazing. There's a bunch of engineers, and you can't take off little parts of the equations. That's why I keep making them accountable for the physics. Yeah? Is that kind of what you asked? Anybody else? Do you know this town is remarkably well known for microbrews? I was just bringing it up. So there's no more questions, you guys?
There's plenty of questions.
I would hope so. I know, but yes, I'll be right there.
How does United States housing compare with Canadian?
He asked how Canadian housing compares with the housing in the U.S. It's interesting. Our perception would be what?
Okay.
It's always better. According to the Canadians, what would they say? It used to be better. Yeah, they're saying that some of the housing in the Canadians have gotten kind of lazy too. And there's I'm seeing Canadians do a beautiful job of vented rain screens. I was in Montreal and Quebec and seeing some just beautiful workmanship. Vented rain screens, an exceptional job of insulating. But again, it's become a choice. And they are spending a pretty large amount of money on research. At NRC in Canada and at the Canadian Emerging Housing Corporation, they have one of the most beautiful research libraries you've ever seen. It's just filled with research that's been done over the last 30 years in a library where you can't get to it unless you're a Canadian, right? No, Canadians are phenomenally generous. If you go to the CMHC website, just Google CMHC, Canadian Emerging Housing Corporation. There's some of the best data and information on commercial, residential, multifamily, fire, everything that you've seen. They've done phenomenal amounts of tremendous research, and it's available on that website. Most of it's free, and some of it you can download the entire report for like, $2 or something. but it's a tremendous place to find information. So part of the challenge has been in certain regions of Canada, we're seeing better construction stuff than we are in others. A lot of it has to do with inspections. In some areas where there's nobody looking, they build whatever they can, and they do it in the name of price. But I think in terms of true responsibility, the Canadians have done a pretty remarkable job. Now, when I told you about what's going on in England, that's because Canadian Mortgage and Housing Corporation has sent a really bright fellow, one of my great friends. His name is Oliver Dreyer. Oliver Dreyer has now been put in charge of international relations from the Canadian Mortgage and Housing Corporation. He's been all over the world, Russia, and he's been all over Europe. He's been in Korea. His son's in Korea right now, helping change the way houses are being built as an emissary from Canada. And he says we're having almost more success converting in other parts of the world to building better buildings than we are in our own backyard. Does that ever happen here? We're always everywhere else telling everybody what else to do, but here we're like, yeah, but we don't have to do that here, right? So it's interesting. Yes, sir. Go ahead. No, you had another question?
Well.
Oh. You don't need a microphone. You're good.
I had a question.
Oh, please. Yes, sir. I'm sorry.
You're talking about all this building physics, and we have seen in different places of the states, Kansas, Florida, Louisiana, Mississippi, and the Caribbean. When you talk about building houses that withstand 100 years, and take into account hurricanes, what's your approach on that?
Well, just don't live there. You know? See how easy that was? I totally had that figured out. See, it was a piece of cake. Can we build buildings in those marketplaces that hold up remarkably well to adverse weather? Yes. You know, when Hurricane Andrew went through Florida and just blew the place apart, the insurance companies went back and found out nobody was nailing down the roof sheathing. Half the staples missed the entire trusses. There were no hold downs on the exterior, and they were using staples instead of nails. So they went back, and the insurance industry and the code industry in Florida changed everything and said, you got to actually nail, and you actually have to hit the rafters, and you have to use tie downs. The next hurricane came through, and they didn't lose any roofs. Can we build buildings that are more respectful and sensitive to the markets they're in? Or is there technology and techniques for keeping wind-driven debris from hurricanes from blowing into houses? Coastal regions along the Gulf Coast have to do what in terms of hurricane? 140-mile-an-hour winds, right? And they have to be free, at least the coastal ones above 140 have to be able to stand the wind-driven debris. Now, the window manufacturers then had to come up with, you know, if you knew this, you guys probably know this, but manufacturers had to be able to take a 2x4, shot out of a cannon, at a window at 35 miles an hour, into the glass and not go through. Are they able to do that? Of course. We have the technology to shoot. I was at the Anderson window plant, and the engineers were doing rock, paper, scissors. Who gets to fire the cannon? Oh, you got to fire it yesterday, you know. And you take a 2x4 and you fire it at a centerpiece of glass, and you watch the 2x4 bounce off. You also have to fire another one at the rail on at the window. If it's a double hung window, it still's got to make it. Somebody basically said one time, they go, yeah, but in Florida they build a lot of CMUs. So if they're using concrete masonry units on the first floor because they think that's for termite protection because termites can't climb. So they have a CMU. So somebody said, well, what if we fire a 2x4 at the same speed at a CMU? So they did that. What did the 2x4 do? Right through the CMU, right? So I just want to know, this is a tip. When you're in Florida in a hurricane, stand in front of the windows. Just stand in front of the window and go like this. Bring it on. Come on, I stand in front of the window. But I'll just tell you, we have the capabilities. I think we have the technology that you could look at things like ICFs and other technologies that in certain marketplaces we could build more durable buildings. And acts of God, as they say, incredible forces of nature sometimes kick our butt. But do you think we should ever really be living in New Orleans? It's 8 feet below sea level.
There's parts of it, just historic New Orleans is, there's sections of New Orleans that are very sustainable, but the vast majority of it is overall.
Well, but here's the catch about New Orleans. New Orleans is a remarkable place. Do we have the understanding and technology to put dikes in when we know what the storm surges might be? Has anybody else in the world figured that out? The Europeans have dikes that'll handle a 72-foot swell in the North Sea to protect Amsterdam. How long have they been working on that? Continuously. They go, what's the potential for a hurricane in the North Atlantic to cause an ocean swell at what level? Let's build it just a little higher than that. What do they do in New Orleans? Let's add some more dirt to that little mound, right? So we knew the dikes were going to fail. We knew the pumps were old, and nobody invested in the technology. We've now spent tens of billions of dollars. The place is still a mess, and everybody knew it was going to happen. So when are we going to change that approach? Can you live in New Orleans and have a properly installed dike to manage the weather and not flood that in a hurricane or the forced flood? Do we know how to do that in Category 4? Do we know how to do that? Of course we do. We choose not to. So that's the catch. We either spend it now or we spend it later. To improve those dikes over the last 20 years, which we knew was a problem, would it have still been less money than we have still been spending in New Orleans now and all the coastal regions? So we'd rather have first cost drive our decisions, because the long-term cost would have been far and away cheaper. What were the odds that a hurricane was going to strike New Orleans? Is there any proof that that was maybe going to happen? It's been a rumor. There wasn't really much evidence, but they'd heard that that could happen, right? So it's ridiculous. It's kind of embarrassing. I think we know how to do this. We have some of the finest engineers on the planet Earth, and we choose not to do that in the name of first cost. Anybody else?
Yeah.
Yes, sir.
I don't want to beat this cost issue to death, but it's an issue that's beating energy efficiency advocates to death, because we don't have a sufficient database to go out and do the proper messaging and make the proper arguments. So earlier you suggested that everybody bombard me with emails about cost studies. My name is Harry Mizzarello. I'm with ACEEE. I'm in the roster here, and working with our sister organization, Building Code Assistance Project, on trying to compile some cost data.
Awesome.
So look me up or look Mike DeWine up and send us your cost studies so that we can compile this stuff, because we just found out in the state of Ohio it's going to cost the average house $15,000 to meet the 2009 IECC. Oh wait, that was last week's price. It's now $25,000 according to the Ohio Home Builders Association. Oh, yeah. And this is after they rolled the code back to a less efficient level below the 2006. So we have a real hard uphill fight. Yeah. And I mean, some of it gets to the mandatory nature of building codes. Yeah. And everybody prefers voluntary programs. The voluntary programs give you, at best, single-digit penetration rates. Yeah. Yeah. And 95% or 97% of the houses are built the way you showed us in a lot of these pictures. Yeah. So, you know, anything anybody in this room could do to do two things. One, the cost data, and secondly, provide sources of home builders that are willing to get up and speak to this, saying that we can do this. You know, the housing industry, you know, dropped about 48% in sales over this depression or this recession. Yeah. The market for the 50% tax credit homes went down 6%. Right. All right. So efficiency is holding its own in the marketplace. Right. And you know, we hear different stories that energy efficiency is number 9 on the list of what people are looking for in homes. We see other surveys that it's number 1. Right. You know, so we got to get at this and make the proper arguments to the decision makers, which in this case are code officials, when they vote on this stuff. Well, I agree with you. One of the recommendations I could make is just to hire Bruce and send him to Ohio. Tenacious fellow. Is Mike DeWine here still? You know, what happened in Michigan? Was Michigan a problem? Yeah. Oh my goodness, I was in Michigan. What a nightmare. They wanted to take their code back to 1982. I mean, they were like, well, that'd be fine. Think of how many more people could buy houses. What an interesting experience that I've been in all those states and watched that exchange. Is there enough data? Diane and I talked about this at dinner last night. Is there a need for more case study examples of incredibly successful projects that work? Is there a need for that? Can we fund that and get that to people? And how many people have done it? In this room, how many could say that they have data that you know of or have access to that looks at the performance of buildings and some cost data and has some numbers of performance? Anybody in this room have? Just raise your hand if you know of stuff. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what if we all combined that and did a much better job of disseminating that information to those folks? Because when you get that data, ACEEE, what an amazing organization. Is Bill Prindle still there? No. No? Is he?
Well, I like Bill. He's a nice guy.
They had to hire 3 people.
Is that right? To take Bill's job, no kidding, he's amazing. I served on the board with him for IDIVA. So if you think about the idea that more data and more information could be incredibly powerful, because that's what everybody's, well, give me the data. And you're like, what do you think of this? Here's 4 studies and here's 4 reports. Here's 9 builders that are doing this. If you don't know Vernon McCown with Ideal Homes in Oklahoma, he's a phenomenal guy. If you want to bring in a builder who can absolutely blow you away, a phenomenal communicator, an exceptional builder. Him and his partner are doing it. They're the #1 builder in the state of Oklahoma. And as far as his ability to communicate to the NAHB, he does a tremendous job. Ron Jones is currently trying to really push NAHB really, really hard on these energy issues. And so Ron's up in Orcas Island with Green Builder Media. So there's a lot of people, you'd be surprised, who are driving as best they can the same bus that all of us could do a better job by having better information. So, Michael.
I think, Bruce, did you want to go first?
Yeah, I just got to take advantage of Mark being here. To say that in Minnesota, you talked about how important ventilation was. People got to breathe in houses. We were followers. We were followers in Minnesota. Don Stevens worked his tail off up in Washington, got ventilation in. We've got Vermont, and we've got several states now have mechanical ventilation. But one of the things we did, Mark talked about this too, how important it was to understand that as we build these houses tighter, we still got ventilation fans, and we still have atmospherically vented appliances. That it doesn't seem that people are kind of catching on to that. But let me just mention something that may give you an inclination to thinking that you ought to require maybe makeup air. We put makeup air in Minnesota's code, and how many furnaces have you seen since 2000? How many houses have you seen with gas heated houses that don't have sealed combustion? Would it be one? Have you seen one?
I've never seen one.
Have you seen a single one?
As soon as
every house in Minnesota is 90% furnace.
Since 2000.
Every house.
Yeah, every home.
We are on the average, we're 35% better than the energy code house. Yeah. Every house, minimum code.
Yeah.
All you got to do, completely, not violating any federal supersession of states requiring higher energy standards, because we didn't require a higher energy standards. We said, when you put an atmospherically vented appliance in, you're going to provide makeup air. And they said, hey, we'll take the easy way out.
Yeah, the easy way out was sealed combustion. They had to put in a makeup air unit for atmospherically vented appliances, which cost them $900 or $300 to go sealed combustion. It was called Market 101, right? Market economics drives people's decisions, I think. Mike?
Mark,
thank you, Bruce.
That's a great point. A couple things. First of all, Harry, I think the HERS industry the ResNet and the HERS industry has plenty of cost data and plenty of cost analysis. I mean, every home that's HERS rated has that economic run associated with it. But Mark, this is a question for you, and this is a struggle I think that I've heard this discussed, that I think a lot of us in this room have a technical bent to us, and when we are trying to affect change. We're trying to make change occur, and that's what code is for many of us. It's change, and again, I'm stealing my thunder from tomorrow, but change equals pain. That's the other kind of a constant in the universe. So change is scary, change is pain, and the fear factor is how we get numbers like $15,000 or $25,000 to go to the energy code, which are absurd, obviously. But I think a lot of us on the technical side, we approach it like, I've got really good numbers to prove my point. And there's an emotional argument that says, I don't believe that. No, we can't do that here. That doesn't work here. There's a case study, but let me tell you that where I'm from, the C word is California. Okay, that's the bad word. That's the land of fruits and nuts, right? And so if something's from California, that's going to discredit us. But if I can get something from North Carolina or something from Alabama or something from another place in Georgia, then suddenly there's a little bit more validity to it. So I definitely want to emphasize that I think there's a regional aspect to case studies that you should definitely be aware of. Yeah. And frankly, your issues here in the Pacific Northwest are very, very different than my issues in a hot, humid climate,
right?
Mixed humid climate. So
yep.
I think that's very important to consider.
Yep.
But the other thing is I think that we, as a technical group, have a tendency to want to say, oh, well, you didn't believe my 50 case studies, so I'm going to go get you some more. And here's some more tests, here's some more data, here's some more case studies to prove my point again. And look, I improved the decimal point by a little bit more, but we're still battling an emotional resistance. So how do we break that down?
Yeah, well, that's the great challenge that we all have, isn't it? Aren't there people that most every major scientist in the world has said that there's absolutely a challenge going on with climate change, and we found out that the only people that are saying no, that there isn't one, are hired by who? So it's really clear as a bell. Clear as a bell. We know that, yeah, you're a utility. But it's clear as a bell there are people that are being hired to discredit the fact that there is probably global change of some type. And now people go, oh, good, that's what I was looking for, a reason not to change. So your point is pretty well taken, that we allow ourselves to do what's easy. When I'm talking to builders in their sales areas, I talk about sales agents. Sales agents are probably our biggest disaster of all, to be honest with you, realtors. And I just watched that whole experience. I do a bunch of secret shoppers with builders. And in Sacramento, I did 6 different builders in Sacramento. Went out to the sites and said, I'm looking for a house, a non-contingent sale. I heard you build some energy efficient stuff. Tell me a little bit about it. Yeah, they're good. Really? Okay, so tell me a little bit more about this. So of the 6 that I went to, a couple of them I had to encourage them to have me fill out the card, but with my name and stuff on them, right? They couldn't even get that right. It was, hey, why don't you go look around and tell me what you think, all right? So then when, after about, what's been 2 months, in 2 months, how many calls have I gotten from people wanting to see if I'm interested? 0. I did the same thing in San Antonio. Went to a builder down there, and the builder said, would you secret shop for my product? I walk in the door, there's 2 models. Nobody in the first model. I'm kind of walking around to go to the second model. I can hear some rustling papers. Somebody's moving something around. I go, okay, there's a body here. And this younger kid comes walking over, and he goes, oh, hi. You looking for a house? No. I was looking for the bathroom. The gas station's plugged up. I thought I'd stop by and pee here. Right? Yeah, well, I think I'm looking for, what a stupid question, right? Yeah, that's why I came here. I had nothing better to do. I thought I'd just kind of cruise through a model home. Is there a chance that I'm probably interested in something different than where I live now? Absolutely, of course. So I said, well, I'm from Canada, and I'm thinking about building, moving to San Antonio. I'm thinking about buying a house. And I said, you know, I don't have a contingent sale or anything, but I said, I heard you guys build a pretty efficient home. Yeah. Okay. Do you guys, we use low E windows in Canada. Do you? I'm pretty sure. I said, okay. And he goes, so if you have any other questions, I'll be over in the other model, and stop on over. You can go ahead and look around. Now, as a buyer, do I know where the bathroom is? It has a toilet in it. I look in there and I go, there's a bathroom. Where's the bedroom? It's the room with the bed, right? So I kind of go, that's the bed. And so I walk around and I kind of go, okay, this is a house, right? So I walk out and the guy gives me this pile of papers. And there's a bunch of, and there's floor plans reversed both directions with a pricing page. If you have any other, oh, by the way, he says, there's an elementary school right up the street. Now, do I have any kids in elementary school? My kids are in college. Should he have asked me if I had kids in elementary school? Because if I have kids in college and I'm looking for the elementary school, he should be concerned. Right? So I'm not getting any feedback here from this guy. So then I leave, of course, and the builder that hired me had me come the next morning to address sales staff and then production. And I come in the morning, and it's all, this is what happened. So I go home in the morning, and then there's a little breakfast, and the realtors are coming in, and I'm getting a cup of coffee at the table, and here's this kid comes up. And he walks up, and he goes, hey, oh, shit, like that. He got it, like that. And I said, Jimmy, what's my name? And he goes, I don't remember. And I said, it was last night. You should have remembered me. I was a potential client that showed up wanting to buy a home from you, engaged you in a discussion, and you have no idea what my name is. And it was quite, he goes, well, you're from Canada. I'm like, yeah, way to narrow it down. Kind of a big country, you know. You could have asked me what city I was from. So you guys, our big disconnect is from the builder, and then he says the consumer isn't interested. I can prove because they don't ask for it. I'm like, well, what's the gap in here? You know, like somebody that is completely incompetent and incapable. Some of them are brilliant. I've met 3. So some of them are really good. Seriously, there's some very good real estate folks that I've had the pleasure to work with. But if that's that connection between the consumer and the builder saying that this is what I want, and you watch that sales process, we're in trouble right there. How much effort is being spent on getting sales agents knowledgeable about energy efficient homes? Almost nothing, right? Very little is being done for those guys. So I think as a whole, there's our interesting gap to buyers. Because when I do some sales training stuff, you know what I make them do? Give me a feature and a benefit of building an energy efficient house. Vernon McCown in Oklahoma, he makes their sales agents take somebody through and show a benefit and a feature.
Mark,
yeah.
Mark, we know that you're passionate, and I'm almost about got a tear in my eye.
You told me,
but we have people that have to get on the boat soon, and we know how that went last year.
You said 45
with
minutes,
a couple of us.
Okay. Well, thank you. Bye.
We have one more.
Okay. Thank you, Pam.
Okay.
Quick, I'll be fast. I'll answer this quickly.
You showed the web trusses for the floor as a way to. What's your opinion about the insulated roof deck?
Okay, it's good.
As a way to get insulated.
Okay. Before what? I was being a smartass. You said before what? They're insulated roof deck? Oh.
Insulated roof deck to get the HVAC inside.
Yeah, I'm a little concerned about a couple, just really quick things. I'm a little concerned about us insulating the roof deck, taking out the ventilation provision, because I'm concerned because I think that shingles leak and I think roofs leak. And so my little concern is that I'd like to see, Tyvek has a product called attic wrap, if you've ever seen it. They have the trusses, and you lay the attic wrap across and you put a cap over each one of the rafters that creates a little space where you have a vented membrane, and then you put the roof deck on top. And it's a vapor permeable, plus it lays over. It's got a little sticky piece. They've actually shown how you can get an airtight assembly. You can then insulate from the bottom side and cathedralize the insulation, giving some ventilation for forgiveness should the shingles leak, insulation in the attic space if you choose to condition it. So condition attics can be a really good step as long as we still follow the physics principles. What everybody wants to do is go foam the roof deck, you're going to be fine, condition the attic, it's over. And I think that we're going to have to do make sure the same principles apply. So have a really nice boat trip. Thank you all very much for coming today.